To talk about our schedule, we're going to be jumping into effectively chapter 8.3 today. Because of a lot of things that have changed in the world of Android in the past 2 years, going back to 2018. There's some big changes that came in 2018 and just finally have been sort of made stable early 2019, and they're really still kind of becoming part of the framework, and people are starting to switch over to those tools. So because of that, a lot of the things covered in lesson 8 are not necessarily applicable anymore, specifically 8.3. So if you're looking at perusal, you will see that, for instance, that I put some videos in here instead, and I put a different reading assignment up for the WorkManager, which I've moved the due date back to Sunday because there's enough reading material there. So that's your reading material, but this was just going to cover what we're talking about today is this WorkManager and our developers. So there's about 35 pages to that, but that's what we'll be talking about today. So the place that this was introduced at Google I/O in 2018, and that's still really the talk from there is still, I think, the best explanation of where this fits in. So that's what we'll be watching. There's also another talk they gave later towards the end of 2019, around November, December, that then updates on other things that have come along, because the first talk, while it gives a really good explanation, they gave it while it was still in alpha, so there were a few things that have changed and when they actually released it later in the year. Cool. So we'll be watching through these two videos as the first part of class. They're about a half hour a piece. We'll take a 10-minute break in between. And then after that, we'll go through an actual code example of, how can we kind of put this together. My thought on this, and I was kind of looking at, what to do for lab assignment and what to do for code examples and stuff. And what I kind of landed on is I don't know that there's a way for me to give you like a lab and a coding assignment that's necessarily different or separate. And so the way I'm thinking about approaching that is we'll do a code along today with one application, and my plan tomorrow is to do another code along with a different application, so you can get a feel of where this fits in and how to build some of these things. Okay. And
get the popcorn. We're going to watch it.
Can everybody hear?
Yep, we can all hear it.
Hi everyone, my name is Samir Kataria, and I'm an engineer on the Android team. I work on architecture components, and today I want to talk to you about a new library we have called WorkManager and background processing in general on Android. So let's talk about background processing in 2018. What are we trying to do these days? Just this morning, I was trying to send a picture of my lovely wife and my beautiful son to the rest of my family. So that's an example of background processing. We're also sending logs, syncing data, processing that data. All of this work is being done in the background. And on Android, there's a lot of different ways you can do this work. Here's a lot of them. You can do things on threads and executors, using job scheduler, alarm manager, async tasks, etc. Which one should you use, and when should you use it?
So that's this is the big thing I wanted to point out. You see that huge list?
Yes.
Yes. Going back to, just in recent years, going back 2018 and even into 2019, this is all the stuff you had to know. Like, you needed to know everything basically on this list that historically has been the thing. And so in reality, a lot of these things by themselves are a lesson. So you're talking about to fully understand everything here, you're talking about 10 lessons or potentially, even up to 5 to 10 weeks worth of content to understand everything that's going in here. So where this is going is the thing that we're talking about today, which is WorkManager, is effectively going to replace a lot of that stuff. Not all of it, but a lot of it. And so, as I mentioned, Alarm Manager, which is 8.2, that's here on that chopping list. Or Jobs, the Job Scheduler, which is 8.3, also on the chopping list. So I think one of these lessons there was the async loader. I think somebody had comment on that and asked it, hey, are we going to use the async loader? Long story short, we don't need to use async loader because WorkManager does that better. Does that make sense?
Yeah, so these that they're listed here, first I just want to point out, I saw 2018 on there, so these things are, they're still possible to use, but they're dying and they're obsolete. We can at least say that they're obsolete, yeah?
It's possible to use them for devices that are older. It actually turns out on APIs, even just starting back as far as Oreo, there start to be a lot of cases where you can't use these anymore from Oreo on forward, from 8.0 on Android 8.0 on forward.
Okay, so they exist in that there are still people that are using, say, API 21, 22, but we'll gradually get past that, and these will be obsolete at that point.
Yeah, at that point, like if you're designing for API 30, a lot of these things on this list won't work anymore, or they won't do the job that you think that they should do, or have that behavior.
Okay, but async task is here to stay.
Async task is not even here to stay. That one actually isn't even here to stay. That's one that's popularly used. We still went over it because many apps are using it, and they're using it in a place where WorkManager doesn't work, where WorkManager doesn't fill that need. So it still falls into something that WorkManager doesn't cover. But what Android has specifically said is basically the replacement for using async task is to use executors, if that makes sense. So the even async task is moving to something else, which is executors and thread pools. Okay.
All right, that's just as important stuff then.
Yeah. So like this whole world is shifting. I was surprised that this talk was 2018, that it was that old, because this stuff is all really new to me. And to be honest, like this is the first semester that I will be teaching WorkManager. We went over Job Scheduler last year, and that was my first semester teaching Job Scheduler. So things have been pretty rapidly iterating, and so this content here is pretty bleeding edge. Okay, it's very much brand new.
Notwithstanding the 2018 date.
Notwithstanding the 2018 date, this stuff is bleeding edge, and so this is stuff that's well beyond, like, you're not going to find it in a textbook. The only tutorials that I was really able to suss up are the ones from Google themselves. And actually, most of the things that I looked up basically reference back to say, hey, watch this video at the end of the day to find out more. So, notwithstanding, again, the 2018 date, this stuff is like just hitting the market today, if that makes sense. Still just hitting the market in 2020, 2021, because there's a lag between when Google builds something and when you can really use it, if that makes sense.
Yep.
So, all right, back to the video. That's the main thing I wanted to interrupt is this is why this has messed up our whole schedule for lesson 7 on, is because of all of the hiccups and all the changes here. So we'll take about a 10-minute intermission, and then we'll do a short QA session for any questions that you have. So you can use that time to kind of compile your thoughts and questions that you may have on the material. And so we'll do that after the break, and then we'll come back after the QA and watch that second video. Okay, so it's about 1:33, so floor is open for questions.
Do they do all of these talks in Kotlin? Is that like their base showing program?
They do. So Kotlin came on the scene about 5-ish years ago, and so it's been a growing sort of phenomenon. It's basically another way to write Java code. Today there are 3 different dialects basically of Java. One of them is Java, another one is Groovy, and the third one is Kotlin. So you can actually basically write Java programs in any of those 3 languages. Java, Kotlin, or Java, Kotlin, or Groovy. They all run on what we call the Java runtime environment, and so basically they generate roughly the same bytecode. So what has happened though, Kotlin is, to be honest and blunt, Kotlin is a better language than Java. And so it has gotten a lot more modern features and a lot more updates that Java never has. And part of that is because, the leadership of being under the Sun umbrella and now under the Oracle umbrella, there's a lot of pushback unfortunately, in the people who kind of own Java or are using Java to adding new features to the language, which has really, really held it back. And so Kotlin is, kind of a new branch of that, has allowed us to take on some more modern and some better approaches to how we code. So you're going to see most of the newer examples from the last, say, 3 to 5 years are pretty much mostly going to be in Kotlin, because a lot of Android development has moved from Java to Kotlin. You might ask in there, well, why, if Kotlin's better, why are we learning Java? Right? Why am I not just teaching you Kotlin?
It's probably just for legacy reasons, yeah.
It's not just legacy reasons. What I've heard from recruiters over and over again is that they want Java developers, and they can't get enough of them. And so what we've heard from industry is resoundingly that they want Java developers, and not that they want Kotlin developers, if that makes sense. So even though the world of Android, I think, has fully moved on to Kotlin, a lot of the development jobs locally are actually in Java, and there are very few writing Android apps in Kotlin.
I think I saw some chart. This is back during our first semester. We were looking at what the typical pay is for developers in certain languages, and Kotlin was way up there. I guess it's really niche, and you can't count on getting a job knowing Kotlin, but if you do find one, you'll be well paid. Something like this.
Yeah. If you're going to get a job doing Android apps, you're more likely going to be doing them in Kotlin and earning a pretty good salary, a very good salary. The catch, and the thing that isn't in those statistics, if you purely look at the price, the salaries, it doesn't really reflect the whole story, right? So it may be that the average developer for Java is, say, 60 to 70K, versus the average developer in Kotlin is actually 100K or more. There's a few things in there. First of all, as you had pointed out, yes, there's fewer jobs. So there's actually fewer people doing Android development than there is Java. And I'd say that number is anywhere from 1% to 10% of people doing Java development are doing Android development. And of those people that are doing Android development, most of them have been in the industry for 10 plus years. A large number of those people that are doing Android development have been in the industry in 10 plus years. So most of the salary difference actually is just down to the years of experience, if that makes sense. The years of experience and the rarity of Android developers in general.
Okay, yeah, I figured there was something more to the story. Otherwise, I mean, why not just learn Kotlin then?
Yeah.
Yeah. Are there many Java jobs in St. Louis? I guess so, right?
Because there are a ton.
Yeah.
I am surprised by how many there are. I'm surprised by how many people have said, Daughtry's told us Java, Java, Java. We want Java developers. I've heard enterprises using Java, and I feel like there's a few others. But if you look at like on Indeed, for instance, for Java jobs in St. Louis, it's astounding how many there are. And it's much, much higher than the number of jobs doing if you look for Android development.
Okay, so that was my next question: does Java equal Android in this sense? But I guess not.
Yeah, it doesn't.
It's just
that's the
what would you use Java for outside of Android? I'm just trying to picture it. I mean, we did some simple math apps in the beginning, but that I don't see that being the big thrust of it.
The answer is you can build anything in Java. Whether or not you should is a different story, but you can actually build anything in Java. So you can build console applications in Java. You can build graphical user interfaces in Java using something called Swing. You can build, as we've done Android apps. I'd say though more than half of the Java jobs, most of the Java jobs are in actually web development. Most of the Java work locally is in doing web development, working with frameworks like Spring and Hibernate, and Java Server Pages and Java Server Applets, servlets, etc.
Is there a timekeeping thing in Java called Deltek? Is that one of their things? I think that was run by Oracle. I just remember it being enormously difficult to deal with and buggy, and that falls into that category of just because you can doesn't mean you should.
I don't know. But what I do know is that I occasionally see apps in the wild that are running on Swing, Swing user interfaces. So, for instance, when I was several years back, Hardee's actually came out with a ordering thing where you could kind of go to the touchscreen and place an order, and rather than going to the counter, and so you could place your order for your food on a touchscreen and then just go take a seat. That was very clearly, I could tell because of how Swing looks, that was in Swing, right? So Hardee's even has a Java thing that they were using for customers placing their orders.
Those point of sale systems we see, I see mostly at coffee shops, where you sign with your finger and all that. That's not Android, is it? I don't think it is. It's not an Apple product. Is that pure Java machine?
It's very varied. It's everything actually. So there are point of sale systems that run on Java. There are point of sale systems that run on Windows, on Microsoft, and they're built in either C# or C++. Like those exist. Technically, you can build point of sale systems with Linux as well. So that can really be anything. Some of the more modern ones may be built off Chrome OS even, or Android.
What about Swift?
Swift is generally a no. Simply
because Square and all that.
it would need to run on an Apple device, right? So Swift is only for Apple devices. So you would only
like,
see that if their point of sale was running on like an iPad, if that makes sense.
yeah.
So that's basically the only thing that Swift can run on is an iPad is in that case. So there are some, there you may see, there may be some cases where there are Apple devices at the point of sale, but I'd say that because of the cost of that, that's a little bit rare. So does that kind of make sense? That's the only reason we've stuck with Java is because the job market has told us to do so, if that makes sense.
Yeah, one comment about the video too towards the end, I think it was in the last 3 minutes or so, there was the do's and the don'ts, and they didn't say it explicitly, but it pretty much said don't use the UI thread. Is that what I was picking up there? Don't use the UI thread for the background task or something? I think
That's
you know what the part I'm talking
that's
about.
not what was said, no.
Oh, okay, I interpreted it wrong. There we go. That's it.
So
that's the one.
it is, yeah, your interpretation is wrong. It is UI related. So what they're saying is typically WorkManager stuff, a lot of it is not necessarily hooked to the UI. A lot of times, if you have a tight connection between between the code that you need to run, quote unquote, in the background and the UI, then you may be better off, then you're usually better off using like a thread pool or an async task. Does that make sense?
I guess so, yeah. I don't fully understand it, but I get the idea.
Yeah. So these cases, like the color palette, all the 3 examples that they say not okay, those would be okay things to do with an async task potentially. But they wouldn't be things you want to do with the WorkManager. It gets very weird because the reality of the thing is there's a lot of stuff you can and should do with WorkManager that does interact with the UI, where the UI is updated based on the stuff that's happening in the background. So it's not a hard and fast rule. The line between what you should use WorkManager with and what you shouldn't is a very hard one to pin down, has been my take on it. Does that make sense?
Yeah, secondary or maybe like tertiary effects of what's going on can affect the UI, but that you wouldn't just do it to change the UI just for whatever reason. It has to be a result of something. Yeah. Whatever. We'll see it. No. We'll see it more.
Yeah. So does that answer the question on Java versus Kotlin? Going back to Corey's question.
Yeah.
So. I will say, just to finish that off, if you want to do Android development and if you want to go forward with that and make that something you do professionally, yes, you should learn Kotlin. But if you plan to do web development, there is not a lot of web development being done in Kotlin. Cool? Not that it can't be done, it just isn't the popular language. Any other questions? There's a lot of,
no.
There are a lot of new words and a lot of things that were mentioned in that video that we haven't seen before, so I would expect a few more. What are some of those words? What are some of those things that were mentioned that you maybe haven't heard anything about?
Well, just my impression. I mean, it looks like it would be something that I would want to learn because it seems easier than what we've been doing. Like learning the tasks like we have this week, with the void with the big V and all that. Oh man, it's a lot going on. This seems pretty straightforward, and once you get the hang of it, I guess it's supposed to. That seems how they're pitching it. It's like, hey, do this. This is a better thing.
It is a lot more straightforward than what we used to do for a lot of these things. And it is a lot more efficient and also a lot less error prone. It's just straight up better than a lot of the stuff that we used to do. But you kind of saw his graph where there's, the 4 quadrants. There are still things where sometimes you need something else.
Yeah, it seems like what we're doing here is mostly downloading and uploading files. That you use picture uploads quite a bit as a sample.
Yeah, that is a very, very, very common thing that fits into the WorkManager. In fact, basically, that is the only way to do it. If you're going to download or upload large files, you have to do it with WorkManager, basically. Also, things that you have to do with WorkManager today are notifications. If you want to have like a notification for when there's a new post, that requires you to use WorkManager. Corey?
No, sorry, I was copying something.
That's fine. Any other questions? Okay, so I'm going to pull up the next video here. And so this one was from earlier in 2018. This was from Google I/O. And this is from another convention, Android Dev Summit in 2018. I believe he says it at the beginning of the video, but these are about 11 months apart.
Thanks for coming. Welcome to the Working with WorkManager session. My name is Samir Kataria. I'm a software engineer at Google.
Hi, my name is Rahul Ravikumar. I'm also a software engineer at Google.
And we both work on Android architecture components, particularly WorkManager. Let me grab my... All right, so what are we going to talk about today? We're going to give you a State of the Union about WorkManager. It was released at Google I/O. I want to give you an abbreviated guide to WorkManager. So for those of you who haven't used WorkManager before, we want to go over some of the basic APIs. And we're going to spend the most of the time talking about WorkManager, the questions you've asked, things that have been frequently misunderstood, and also the new changes that we've made since I/O. So let's start with the State of the Union. There have been 11 releases of WorkManager since Google I/O. And these are alpha releases. Today was the 11th one. And beta is coming soon. So those of you who watched the keynote yesterday may have heard that beta is coming this month. This was news to us too, but it's coming this month. We were very close, but I guess we're doing it this month now. So we want to give you an abbreviated guide to WorkManager. And what is it, for those of you who are just completely new to this? It's a library for managing deferrable background work. It wraps Job Scheduler and Alarm Manager broadcast receivers. It's backwards compatible to API 14. And those of you who've used Job Scheduler will find many of the concepts very familiar. So let's talk about work. You've got a unit of background work, and we'll talk a little bit more about how we create it and how we enqueue it later. But you've got it, and how does WorkManager execute this work? This is a graph that might help you. While your process is up and running, we'll feed it to this executor that we have that does the work. It could be a thread pool. You can customize this thing. But your process may be killed, and WorkManager is guaranteed to do work. It may defer it, but it will do that work when the constraints for that work are met. So we also enqueue it in the background. So if you're API 23+, we use Job Scheduler. And before that, we use an Alarm Manager and broadcast receiver implementation. So whenever the signals are met, let's say that you've put in some work for a 2-hour time delay when you have network, when all of those conditions are met, it'll still go to the same executor.
All right. Let's do a quick API walkthrough for those who have not seen the API. So the fundamental unit of work in WorkManager is a worker. Here I'm defining a calculation worker. It extends the worker type. So now the only thing that you need to do when you define a new worker is to extend do work. Do work returns a result. Here I'm returning a success. You can also return a retry or a fail. I'm doing some expensive calculation on a background thread, so you don't have to worry about threading here because WorkManager is guaranteed to schedule your work on a background thread. And here I'm returning a result.success synchronously. So that's it. I'm pretty much good to go. So now you've defined a worker. How do you actually make that work run? So for that, you need to enqueue a work request. So there are two types of work requests. One's a one-time, and the other one is a periodic work request. Here I'm using a one-time work request builder. And I'm building it with the calculation worker that I just defined in the previous slide. So I'm setting an initial delay, and this is a timing-based constraint. And this tells WorkManager to only run the work after 2 hours have passed since the point of enqueue. I'm also setting another constraint, which is the charging constraint. This tells WorkManager that this work is only eligible to run when the device is actually connected to our charging, when the device is actually charging. I add a tag. I'll talk about tags in more detail, and I'm finally calling .build. Now, all I need to do is to call getInstance and enqueue the work, and that's it. Now the work is scheduled. So now you've scheduled your work, you've defined a bunch of constraints, and it's hard to keep track of, and if you want to keep track of what state your work is in, then you want to call getWorkInfo by ID live data. And this returns a live data of a list of live data of a work info. And so work info is the type that determines the state of your work. And live data here is a lifecycle aware observable. So once you attach it to a lifecycle owner and you define an observer, you can observe the state transitions of the work request. So it'll go something like, once you enqueue the work, it'll go into enqueued. Once the constraints are met, it'll go into a running. And then finally, because you return success, it'll go into the succeeded state. So remember that tag that we added when we built the one-time work request? You can also get work infos by tag, live data. And tag is something that you associate with a work request. And there can be one-to-many. So you can associate the same tag to multiple work requests. And here, I'm calling getWorkInfos by tag live data. It returns a live data again. Notice how it returns a list of work info and not a single work info. And again, I can do the same things that I did in the previous slide. So one of the coolest features of WorkManager is the ability to chain work. So that helps you define an acyclic graph of work. And here I'm asking WorkManager to begin with A, B, and C. And here, A, B, and C are work requests. And I'm saying that D and E are only eligible to run once all A, B, and C are done. And when I use the begin with API, I'm asking WorkManager to run A, B, and C potentially in parallel. Whether they actually run in parallel is determined by the capabilities of the device and the size of your thread pool. And finally, I'm calling a then on F, G, and H. Again, that now F, G, and H will only run once all the preceding works are done. Finally, don't forget to call enqueue. That's when all the magic happens. So now you called enqueue. Now you might be wondering what begin with returns. So begin with actually returns an instance of work continuation. And a work continuation is a node in your acyclic graph. And this lends to a very fluent API. So every time you call begin with, it returns a new continuation. And every time you call .then, it returns a new instance of another continuation. Finally, don't forget to call enqueue. The one important thing that you need to remember is when you chain work, the outputs of parent or the outputs of the parent work request become inputs to your descending work requests or your children. This helps you manage state and send state from the parent work to the descendant work. And so now, finally, WorkManager also exposes the APIs to cancel work. So for some reason, if you want to do that, you can cancel work by ID. And every work request has a unique ID. So here we are canceling work by that ID. And we can also cancel all work by tag. So those are the two APIs. And that's it.
And I want to point out that all the APIs we've been showing are for Alpha 11. So you may notice some slight changes for those of you who have been using this API before. But everything is live today. So let's talk a little bit about how you can get the most out of WorkManager. And these also include questions like, how do I do a certain type of task? Why does this work this way, a certain way? And the biggest one that we get a question about is threading. How does threading work in WorkManager? So we talked about a work request. Rahul just mentioned that. And you enqueue it. What happens to it then? So we have an internal, we call it an internal task executor. You can think of it as a single-threaded executor. And the enqueue goes to that, which stores it in a local database. So every app that uses WorkManager has a WorkManager database. This is the source of truth. This is where we keep track of the state of your work, your inputs and outputs, everything with the dependency chains, everything goes in this database. So after it's been enqueued, sometime later, your constraints are met. And the OS tells you that. If you have no constraints, it's eligible to run it right away. If there are constraints, the OS will tell you, oh, you have network, you are charging right now, whatever it is. Same task executor uses a worker factory to create a worker. Worker factory is exactly what it is. It's a factory for workers. And you can make your own, you can customize and do things with that. We'll talk more about that later. After the worker's been created, we execute it on an executor. And this is also a thing that you can actually customize. We'll talk more about that later as well. But what if you don't want to execute something on that executor? We give you a default one. You can specify your own, but what if you're using RxJava? What if you're using coroutines? What if you have your own bespoke solution that you want to use to run things in the background? This was a request that came up quite a lot when we first released WorkManager. So to do this, we want to provide you an API to let you do work on your own and just tell us when it's done. So you want to signal async work completion to us. And for that, we use a class called listenable future. Those of you who use Guava will be very familiar with this. But we split it out, and the Guava team has helped us with this, so everybody's collaboratively worked on splitting this out to its own lightweight artifact, so you don't need a full Guava dependency for this. It's literally one or two classes now. And it's a feature that can have one or more listeners, and those listeners can be invoked on a specified executor. That's all it is. It's very simple. So using this listenable feature, we made a class called listenable worker, which only has one method that you need to override. It's called start work. We'll call start work on the main thread for you. You give us back a listenable feature. You do whatever work you want on whatever thread you want, and when you're done, just set the result on the future, and we'll be able to listen for it, and we'll be able to react to it. So the actual threading model in WorkManager is, after your constraints are met, it goes to the task executor, which uses the worker factory to create a listenable worker. We call start work on it, and we also attach a listener so we can listen to whenever you're done. What this means is that the worker class, which is still around, is a simple listenable worker. So we've got the do work method that we talked about. We override the start work for you. We create a future. On that background executor that I talked about, the one we provide by default, we execute the work. And we, of course, return the future. So now we have two classes, worker and listenable worker. What's the differences between them? Workers, we consider those a simple class. For most use cases, we think that's sufficient, is a class that runs synchronously and on a pre-specified background thread. Listenable worker runs asynchronously on an unspecified background thread. So worker.doWork is a synchronous API. You're expected to finish what you're doing there. If you're trying to create a listenable worker, you may need to return a listenable future, which is an interface. If you have access to Guava, you have access to many kinds of listenable futures. If you don't have access to Guava or don't want to add the dependency, resolvable future is a lightweight implementation that we provide in Android X concurrent futures. So you can use that. So let's look at an example. One of the things that a lot of people are trying and doing incorrectly with workers is that they're trying to get locations. And we're going to specifically use the Fuse location provider client. So if you listened to the Kotlin suspenders talk yesterday, they also use this. It's a GMS core API to asynchronously get your location. Remember that a worker class is synchronous. So if you attach a callback and later get informed about it, but return success, your work is already completed. It's not going to work the way you think it is. So first thing we do here, we're using a listenable worker, is we create a resolvable future. So this is the future that we'll return and do all our bookkeeping on. In the start work method, we'll check to see if we have permissions. If we don't, we'll set a failure on the future. Otherwise, what we'll do is we'll get that fuse location provider's last location. This is kind of like a future in GMS core or Google Play Services world. And we'll call this get location method, which I'll go into, and then we return the future. So that's sort of the high-level start work. In the location get location method, we'll use that task, and we'll add a listener to it. If the task is successful, we'll pass that location back with a success status. Otherwise, we'll set an exception on the future. So that's it. We've basically addressed like the three cases where we want to have a successful or an unsuccessful task, or if we don't have permissions. And WorkManager will attach that listener. It'll listen to the success or failure of your task and do the bookkeeping as necessary.
All right. Let's talk about operations. Now, remember, Sumesh mentioned that WorkManager uses a database as a source of truth. So anytime you enqueue or you cancel work, we have to do some bookkeeping, and we have to make sure we keep track of what your intentions were. So these involve writes to a database, and because there are writes to a database, we have to do them on a background thread. So as a result, they're asynchronous. What if you actually wanted to do something after the enqueue happened or the cancel happened? So you want to make sure that those operations completed before you want to do some more stuff. So for that, we've introduced a new API. So now enqueue and cancel actually return a new type called operation. Operation is a very simple interface. It has two methods. So it has a getState API, which returns a live data of an operation.state. If you attach an observer to this live data, you will see that the operation transitions from an in progress to a successful or a failure. You can also call getResult, and this returns the familiar listenable feature type. And remember that this API will only return the terminal state of the operation. It won't give you the intermediate states. So if you're attaching a listener, you will only ever get a success or a failed, and with the exception of telling you why the failure happened.
Another question a lot of people have is, when is work stopped? What happens when you stop work on behalf of WorkManager? Oops. All right. So there's three cases when work is stopped. The first is very simple. Your constraints are no longer met. So you said, for example, that I need a network to do this upload task, but your network got lost. So we will stop your work at that point. A second case is that the OS preempted your work for some reason. For example, you exceeded the 10-minute time limit that the OS gives you to do your work. Or the device decided to go into doze mode for battery savings or something like that. And the third reason is that you just canceled your work somewhere else in your app. How do we stop work? There's a method, listenable worker on stopped. We call this method when we stop, so just override this and you get your stop signal right there. We also cancel that future that we talked about, so you can also just add your own listener and look for that. So this is when one of these two things happens for you, whichever one you're looking at, this is your signal to be a good citizen and clean up. Because after this is called, the process may be killed by the OS. So if the OS woke up your app's process just to run this work, it could actually kill it when it decides that the work should stop. And if you happen to return something after this signal, say you returned a success, we ignore it, because as far as we're concerned, your work has been stopped. Whatever you're doing is no longer necessary to be done. You can also poll for stoppages in your worker, so you can also call the isStopped method, and that'll tell you whether you've been signaled for stopping. So let's look at how you can be a good citizen and clean up. So let's say in this example, we're parsing a file asynchronously. Let's say it's a huge file, so you're doing it in a worker. And you've got that familiar resolvable future thing that I showed you earlier. You've also got this input stream, so you're reading a file. Right? So in start work, you say parse file. This is doing something asynchronously, and you return the future. Here's parse file. So you've got some executor or whatever, a coroutine, it doesn't matter. You're asynchronously doing that runnable that follows. So the first thing you might be doing is you're opening the file, you're reading each byte out of the file, doing something with that byte, and then when you're done, you set a success because you're done. And then you have the necessary try-catch finally after that so that you can clean up after yourself. So how do we handle when your work gets stopped while this is executing? So like I said, we override the onStop method. Let's say that we want to just finish what we're doing. We could easily just close that input file stream. OK, so what happens now? You've done that. Let's go back to the code. Well, if you're in the middle of that read loop and you close a file, it throws an exception, right? Next time you try to read something. Well, fortunately, you're already handling that exception right there. So it looks like you're good, right? You're done. Or are you? There's one more case that you forgot about here, which is that what if the onStop happens before you even open the file? So now you're no longer looking for that stop thing because you never got that signal. You'll read that file because it opened after you tried to close it, which it didn't do anything for. So you'll do all of this work. And how you fix it is use that isStop method. So basically, while you're in that loop, you can always just make sure that you're looking for stoppages. So this is a good example of how you would honor the OS's signal to you or WorkManager's signal to you that you should stop and be a good citizen.
Right. So every time you enqueue a method, every time you enqueue a work request, the work request goes through several state transitions, and I'll talk about how they look. So let's look at the life of a one-time work request. So when you enqueue a new work request, it can end up in one of two states. It can be blocked, if it's blocked on another work request, given it's a chained work, or it can be enqueued. Once the constraints are met, it goes into running. And this is the point at which the worker is being actively executed. Once, depending on the result that you return, on how you signal work completion, we'll take it to one of the terminal states. So if the worker returns success, then it's a we'll terminate it with a succeeded state. If the worker returns a failure, then we'll mark it as a failure, and that also is a terminal state. At any point in time, while the worker was in a non-terminating state, if you call cancel, then if you actually retry, then we'll apply the back-off policy, and then we'll retry. So the worker will go back to the enqueued state. At any point in time, if you have a non-terminating state and you call cancel, it'll end up in canceled. So this is what a life of a one-time work request looks like. Now let's look at periodic work. Periodic work is almost the same. Because periodic work can't be chained, there is no blocked state. So it always ends up in the enqueued state. Once the constraints are met, it'll go into running. So whether you succeed or you retry, it'll go back into the enqueued state. Now, this might seem confusing. If you succeed, then the work really isn't done because it's a periodic work. We'll just wait for the next interval. If you fail and you ask us to retry, then we'll apply the appropriate back-off policy, and then we'll increment the run attempt count. So we'll tell you that this is the second time that you're trying to run it for that last period. And if you mark your work as failed, then we'll transition it to the failed state. At that point, your periodic work won't run again. And again, anytime your work is in a non-terminal state, and if you ask us to cancel it, we'll mark it canceled. So let's apply those rules to how life of a chain of work looks like. So here, A is the parent of all workers. So when you enqueue this chain of work, only A is in the enqueued state, and all descendants of A are actually blocked now, right? So let's assume A's constraints are met, and it goes into the running state. Once A is done, let's assume it succeeded, so it unblocks B and C now. So B and C now become unqueued, and then they go into running. And for the sake of the argument, let's assume that B succeeds and C fails. What happens now? Because B succeeded, it unblocks D. So D goes into the enqueued state. But notice what happened to E, F, and G. They all failed. So the key takeaway is that if a unit of work fails, then all descendant work is also marked as failed. If a unit of work is canceled, then all of its descendants are also marked canceled.
So I want to talk about something called unique work. And let's start with a little question here. What's wrong with this code? So you've got an application object in the onCreate. You're enqueuing some periodic work. The problem here, and I've seen this in a few bugs, is that this enqueues periodic work every time your app process starts. And that's probably not what you're trying to do. You're trying to set up a sink here. Let's say it's syncing your data every day. If you call this code every time the app starts, every time you've got another thing that's syncing your code, you really only want one of them. So unique work basically is something that lets you specify conflict policies for a database insert. Think of it like that. Like if you insert the same key into a database again, what do you want to happen? Do you want to overwrite what's already in there? You want to ignore what you're trying to do? That's what unique work does. It basically is a conflict policy for WorkManager. And here's the syntax for it. It's pretty simple. Unique name is that key. It's that something that uniquely identifies that chain of work. Policy is the existing work policy, or what we call the conflict policies. And then you obviously have your requests. So the existing work policies are the interesting things. There's 3 of them. The first one is keep, which is it keeps the existing unfinished work. So if you have things that are in blocked, running, or in queued, it will keep them. And if the work is already finished or it's not there to begin with, it'll enqueue whatever you just sent along with that call. The next one is replace. It always replaces the work request in the database. If your work is running, it'll get stopped, as I described a few minutes earlier. It cancels the old work and it stops it. That's what it does. Append is kind of a special one. It basically appends to that chain of work. So for example, this is useful if you're trying to do something in order. For example, you're trying to build a messaging app and you're sending messages in order. So you may have a unique chain of work for sending messages, and you want to append new messages to the end of it. So it's basically creating a tree for you.
Remember, Sumir mentioned that in one of his previous slides on how one can customize WorkManager. So let's look at all the things that you can do. So you can actually specify a worker factory that can be used to instantiate your workers and listenable workers. And this is especially useful in the context of dependency injection. So if you're using Dagger and you want to inject something into your worker before the worker starts, this is a good place to do that. You can also specify the default executor that you want all workers to use. You can specify the logging verbosity if you want to distinguish between a build and a release build, and you want to make sure you log more information to diagnose your problems. And then you can also specify various other job scheduler parameters, like number of jobs that you want us to send to job scheduler, the IDs of jobs that you want us to use in case you're already using job scheduler before. So if you want to customize WorkManager, then you have to disable the default WorkManager initializer first. So for that, you have to add this entry to your manifest and note the tools node remove. That means you're removing this. You don't want this entry to get merged. So now that you've disabled the default WorkManager initializer, the next step is to actually create a new instance of configuration. So here I'm using the configuration builder, and I'm overriding it to specify my own custom executor. So now that I've done that, I can just call workmanager.initialize. I specify the application context and the configuration, and I'm done. So make sure you do this in your application on create or a content provider on create, because the system, the operating system, can actually invoke job services on your behalf. And when job services are being invoked, WorkManager needs to be initialized.
Finally, the last thing we want to talk about before we wrap up is some tips for all the library developers out there. If you're using WorkManager in your library, you have some special use cases that we want to think about. So the general advice we give for library developers is, because WorkManager is a singleton and the application initializes it, as Rahul just showed you, you are not really in control of what's there. Rely on the defaults. So use the default worker factory. The default worker factory that we provide it creates workers and listenable workers using reflection. Rely on that, because you don't know what else is happening. If you need some particular dependency injection or anything else of that sort, you'll have to have a contract with the app. Silo your work with tags. So Rahul also showed you how to tag your work. If you silo all your work, meaning you prefix or put your prefix or your package name or your library name in your tags, you can easily identify all the work that's yours. You don't have to worry about other people's work. You don't have to deal with any of that. You can just get your work and operate on just that if you don't know the IDs. Finally, we do provide the ability for apps to wipe away all work, and this is generally for privacy reasons. This is not something we expect to be called, but it's for that sort of critical use case where you have to wipe user data for some reason. So as a library developer, how do you find out if your work's been wiped or gone from under you? you should look at get last cancel time. Sorry, get last cancel all time millis. It's a very confusing name. OK, next steps. So get WorkManager if you haven't already. And for those of you who have, thank you very much. Your feedback's been invaluable. We're up to Alpha 11. So there's 3 general categories of artifacts here. There's the runtime. There's the KTX stuff, which includes a coroutines worker that we just put in. So you don't have to write your own. And then there's testing support as well. These are some helpful links. Schedule task with WorkManager is the developer.android.com section for WorkManager. There's the YouTube, on YouTube, there's the Google I/O 2018 talk, which talks about all the basics in much greater length. Some of those APIs have changed a little bit, but it's still broadly a good thing to read or to listen to. And also, please file your feedback at our public issue tracker. Beta is coming. We were told that this morning or last morning as well, so we're kind of, we have to go back to work, but thanks a lot. Please visit all the Jetpack libraries on the web, and we'll be outside for any questions that you might have. Thanks.
Thanks.
Okay.
Hey, I got a question right off. Was
Yes.
that Kotlin they were using in the examples? Because I noticed some syntax like I'd never seen before, and they really seem to hate semicolons.
Yeah, you're seeing Kotlin. But I think part of that is a lot of the, near all the examples that they show are fragments of code. I'm trying to see there. So yeah, you'll see no semicolons.
Is that Kotlin right there?
Yes, this is Kotlin.
Oh, shoot. There's any more videos like that, tell me. I was really feeling like dumb.
Yeah, that's Kotlin. It looks very close. It looks very close. So things that you'll see that are different in Kotlin, you'll see that there's like context, context, right? So it's actually very similar to Java. So the thing, the left side of the colon is the name of the variable, the name of the parameter. The right side is the data type of the parameter, which is reversed from Java. Does that follow?
Yeah, instead of big C context, yeah, I get it.
Yeah, it's
swap it and put a colon.
Yeah, swap it and put a colon. That's the difference with Kotlin. That's one of those things, and that's also why you see here, do work result. That's the return type from the function, which normally you would be expecting to see it here, and fun is short for function. So, yeah.
Whoa. Okay, I thought it literally meant fun.
No, fun is short for function. So, yeah, this idea of moving the return type or the data types to the second part, I think Google pioneered that with the Go language, and so it's also made its way into Kotlin. It's one of those things that seems very weird offhand if you've never seen that before. There's a lot to be said for that is a much better way to write code, though, because of the ordering where the data type is second and the name is first. And so that's one thing that some of the newer languages are starting to adopt, because it ends up making your code easier to read if you just flip it. So. All right. Any other questions before we take a break here?
So we got one more video after this, or is this?
Nope, that's it. We'll get into the code example. Code along.
Okay.
So let's say we take another 10-minute break here, and then we'll come back and we'll do any QA we need to do, and jump in and build something from scratch. So we'll come back here at 2:32 and jump into that. Okay, so my recording's going, and just going to open up the floor to questions. Anything to ask before we dive into the code example?
We'll just be doing file uploads then, right? I mean, that's pretty much the only thing you said. We'll be coding along.
We'll be coding along, yeah. But what we're going to do today is not going to deal with files. I'm going to save that example for tomorrow.
Okay, what are we doing?
So what I want to do today, basically, this WorkManager, right? It's good for long-running jobs. So, things you want to run in the background, things you need to do, based on certain conditions, like you have, the battery's not low, the network is, connected, things like that. So what we're going to do today, to just kind of start with an easy example, is we're going to go back to the prime number finder program and move that code. Basically, we're gonna make a version of that uses the WorkManager. Because that's something that's it's long running. It's long running and doing work because it's doing calculations that take time. So that's a lot easier thing to kind of start with and learn the tools with before we jump all the way into like connecting to the internet and mixing those complexities in. Does that make sense? So tomorrow we'll look at files. We'll do another example. We can look at files with the WorkManager and network stuff. But today we're just going to do an example with finding prime numbers using WorkManager. Any other questions? So I'm going to go over to Android Studio, and we're going to create a brand new project. And so this is going to start with an empty activity. I'm going to put this under 8.
Can't see your screen.
Oh, I will fix that problem. I was sharing my just the tab because otherwise you can't hear the audio. Okay, you should see my project now. So again, I'm going to create a new project. Empty activity, and so I'm going to put this under the 8.3 folder, and I'm going to call this prime numbers in class. Or maybe prime numbers code along. But that translates maybe. I don't want a dash in there. Maybe I can just, what if I just remove that dash there? Underscore. Yeah, so let's go with that. Prime numbers code along. And so that's under 8.3. Prime numbers code along is the path that I'm putting in there. So when you get the project created, the first thing you'll want to do is just create packages. Now I'll go ahead and create them here, and then you can kind of get caught up when you get the project up and running.
Sorry, maybe I missed it. The package name that you have.
Yes.
Did you remove the underscore?
I did remove the underscore. Check the
Okay.
screenshot in Discord for the specific settings that I used.
Okay, I wanted to make sure I didn't type the name wrong or something to not get the underscore.
Yeah. Now I'll just pause here for people to get caught up and make those packages.
You're putting the main activity and activity package?
Yeah, I will be doing that as well.
Okay.
I haven't done that yet. So this is the same kind of organization, basically looking at the packages as we've used before. With the activity package, the adapter package, the model package. But you also see that I've added a package for workers now, because there's, we'll need to create potentially a few classes under that category. Simple applications, what we're going to do here is just going to be a single worker. But as your projects get more complex, it's not unlikely that you'll need to create several different workers to do different jobs. So that's where I go ahead and just make a separate folder for that, because it doesn't really fit cleanly into any of the other folders that we have already. Workers aren't really models, they're not really adapters, and they're not really activities, so they're really their own thing. All right, so before we can do anything with the WorkManager, we need to add a dependency to our Gradle file, so that we can use the WorkManager, as well as everything that comes with it. So under your build Gradle, it's a second one called modules. We're going to go down to the dependencies section you can see here, and so we need to add a dependency in here. So I'm going to add implementation. And the dependency that I want is Android X.work and work dash runtime colon 2.5.0. Once you get that typed in, you'll go ahead and hit sync now to sync it up. Add that into Discord so that people can make sure they get the same one. So, and if you've paid close attention to the videos, I think actually both of those videos showed a different dependency than that one. That's the one that's in the latest documentation. So they've moved it around a few times as far as where that package lives. Everybody got that dependency put in?
Yeah.
Okay. Don't forget to sync your package. And again, you can click the little elephant button up here if you need to sync it, if you dismiss the prompt. So we'll add that in there, and that will make the different classes that we need up here. So I'm going to take the main activity. I'm going to move that into activity. Go ahead and hit refactor. It hasn't actually updated it, but it has been moved. It's just a graphical glitch here that it hasn't moved the main activity into the activity folder. But as soon as I create another class here, it'll fix. So I'm going to go under the worker folder, worker package, and I'm going to create a new class, new Java class. And I'm going to call that find primes worker. Find primes worker. Okay. And just like with a lot of other things, if we have a task, an async task, we usually end it with the word task. If it's an activity, we usually end it in the word worker. Now it looks like my main activity still has not recognized that he's moved. And I forget what I had to do to get that to...
Close out your project and reopen it.
Okay. Oh, they're good. I just had to run it on the device. Okay, so in the worker, so what we're declaring is a worker, and so therefore it needs to be a subclass. It needs to extend the worker base class. Okay, so I'll add that in, and it should automatically give you the dependency, basically androidx.work.worker. If you haven't added the dependency to the Gradle, it will still be complaining there and say, hey, I can't find worker because it doesn't know to bring that dependency in by itself. It doesn't know where to find that worker class. So you have to make sure that you do that first. Here I'm going to go Alt-Enter, and it's going to ask me about doing a few things. So implement methods. You'll remember we need to implement the do work method. They mentioned that in there. Workers also have to have a constructor. So I can do Alt-Enter again, and I'll get this here. So find prime, although I think I meant to call this find primes worker. Refactor, rename. Find primes worker. So you need a constructor. That constructor is going to take a context and parameters. I'm just going to rename that to params to make it shorter so it fits on the screen. So I've got a constructor and I've got my do work method, right? So the constructor basically gets called at the beginning when you start the job to set a few things up. And then do work is where the actual work happens on the background thread. So if I remember right, your constructor here will be on the main thread. This will be on the background thread. Okay. So, what do I want to do? I want to be able to, what my goal here for this worker is for it to continuously in the background be finding prime numbers and notifying the front end every time we find a new prime number. So things I might want to think about, I might want to track what my current number is. So private long current. And I might want to track what my maximum number is. What is the maximum number that I'm going to go up to before I stop. So those might be things I want to add as, say, instance fields for the state of the system. So in here, I would say, well, let's start the current at 2. Maybe the first number we try is 2. And then we'll say, let's go up to 1 million. Right. So I'm going to start with initializing those two variables. Things you can do later on, we can pull those from different places. So we could pull them from, say, the input parameters would be one way to pull that in. The input data, or another way to pull it in might be from say a data source or such. We're going to talk about some of the ups and downsides of doing it different ways. But I'm going to just start with those initial values as hard-coded. So now in terms of doing work, right, I know I need a loop, right? So I'm going to loop starting from whatever the current or the starting value is, going up to the maximum. So I'm not going to set an initialization as my first part of the for loop because those are already been initialized in the constructor. So I'm going to say as long as the current is less than the max, let's loop through there. And so every step I want to increment current. So current is the number that we're testing, and maximum is the highest number we'll test. And this should actually be current is less than or equal to max. Okay. Another thing we need to make sure that we do in there, remember that workers can be canceled and or stopped, as you would say. So similar to how we set things up with an async task, we need to be continuously monitoring for whether or not our job's been canceled. So inside of the middle part of that for, I want to say, as long as its current's less than max and we haven't been stopped. And you'll notice here it's unlike async worker, async task, the particular method we called was is canceled here. In this worker, it's is stopped. Even though they call it, even so the method you call is cancel, you tell it to cancel the work. The check here is stopped, not is canceled.
All right, Mr. Smith, what is tell me the reason why we don't have in the for loop there the conditions on the far left? There's no, there normally be int I equals 0. What would explain that?
Because
again?
I'm initializing them up here in a different method. So that way I could say, maybe I want to resume where I left off, right? Maybe I want to resume at 50 or 1 million or wherever I left off the last time this program was.
Oh, okay, all right.
Running.
There's no, your I is already set there on line 16.
Right.
So it would be the same as just doing it locally in line 23 saying int.
No, it wouldn't be the same. It wouldn't be the same.
Well, right, because it would be left permanently there. It wouldn't be a local variable. But in effect, it's coming in as 2.
Because if I set this as like current is 2, it wouldn't matter. If I set this up to some really large number here, I'm setting it back down to 2 here, right? So whatever value I set up here doesn't matter if I reset it down here.
All right, I'm tracking. I got it. We just set it outside the conditions.
So,
all right.
So I'm setting it up here. That's why I don't need to set it down here again. Because if I set it down there, I would be resetting it, changing it from what it needs to be. Okay, so that's where we're starting with that. Other things that we need to remember when we get down here, remember we need to return a result. And do you remember what those? There was 3 different kinds of results you can return. Does anybody remember what those 3 results that you could return were?
Success, failure, and I guess in process or something like that.
Isn't it retry?
Retry. So success, failure, and retry. Okay.
In caps, isn't it?
It was in caps in the slides. They've actually changed it a little bit since those videos were recorded. So in here, and also in those videos, I think they used to call it worker result, but now it's just called result. So it's going to be result dot It's actually a method call now. So it's a retry, success, or failure. They're no longer constants. So it's going to be one of those three. So say this went through successfully, then I'm just going to say result dot success. That's how you say it went through successfully. Now, success means you're done. Success means we've finished the whole job. Don't ask us to do it again, right? But if I get down here, do I know that the job is done? Is it always done if I get here?
No,
Why not?
because it could just skip the for loop, or
Okay.
like the for loop has like factors in it that are required for the success.
Okay. Okay. So what happens if how do I know if I've gone through and tried all the numbers or not? How do I know if I've gone all the way up to max?
Could you set a variable for like to check to see, or like just an if statement that says if current equals max or something?
Right. So if the current gets up to the max, basically I know. But now notice here I do want to check the max. So like I do want to check 1,000,000. So if current is equal to max, we're still not done. We're only done if current is greater than max. Is everybody with me there? We're only done when current is greater than max.
So what's on line 26? We got to check if
Right.
if current is greater than max, then return result success.
Right. If current is greater than max, then we know we're done, and we don't need to resume it. But if it's not, then we need to come back and resume later. And so we'd say result dot retry, because we want to continue that process at a later time.
I'm trying to understand what would call line 29. If current isn't greater, the loop's going to keep running if current is less than max, yeah?
Okay.
So under what circumstance would you get to a point where you'd retry it? Like, yeah, I don't see how that'd be unreachable, I'd say.
Well, look at the loop. Take another look at the loop.
If it's stopped?
If it's stopped, right? If
Yeah.
it gets stopped, is it going to be all the way up at the max? No.
No, but
So-
if is stopped wasn't there, then that would be unreachable code there on 31.
Yes. If it weren't for that check, then there would be no way to reach this case. If it weren't for that check, then there'd be no way to get down here. But since our work can be stopped midway, we need to say, hey, I want to resume that work at a later time. Does that make sense?
Yeah, I get it now.
So, yes, we need that check because of that additional part in your loop. So you do have to pay attention to your loop. You can't just assume that because you got to the end of do work that it was successful. You do typically have to check, was it stopped? Because if it's stopped, then you're going to need to do something different. Another way around this is you could write this as rather than putting it in there, you could say, well, let's do an if statement. If it is stopped, then we're going to say return result retry. In some cases, this might be an acceptable thing to do. The catch with just putting it in this loop is what happens if you get through. What happens if you say you write it that way, no check there, and you just do this? What happens if you get through all of them, but then it's the timing is where it got canceled after you got out of the loop? You may not be covering that case. So sometimes that's an acceptable way to solve it. You might be able to put an if statement directly into the loop itself, and just directly return retry or failure, whatever it may be. But that's the way I'm going to write this here. Is I'm going to loop as long as it's not been stopped, and then at the end, I'll say okay, are we all the way done, or we still have ways to go? And so if we still have numbers to check, then we're going to say, well, we'll retry it later. Okay. So for each number in here, basically I want to say, is it a prime number or not, right? And so if I were to say, maybe write a method here, private boolean is prime, and give it a number to check. So let's try long number. And just to keep this simple for the moment, I'm going to say return true. Okay, put the actual logic there in a minute. So I'm going to say, well, okay, let's just say all the numbers are prime, which isn't true. But if I go loop through each of them and say is prime, is the current number prime, then we can kind of log what we get. So log dot I need some sort of log tag, and so for the moment I'm just going to hard code that as prime numbers, which is the name of the app. And I would say, well, let's just log found prime current. Right. So we've got kind of the skeleton of our worker. Any questions at this point?
No.
Okay. So my goal for this worker is to keep it running as long as possible. It should basically be running all the time. So I want it to be running even when my application isn't running. I want it to be constantly looking for primes. And that way, you know, you can jump in at any point in the process and you can see where it's at. You can see what's the biggest prime that it's found. And so that's kind of where we're building towards. So if I'm going to do that, where do you think I need to start this worker? What class should start this worker? So you basically have, you know, two options from what we've talked about, right? You can either start it from the activity, or you can start it from the application, right? And so the activity, if I say, well, let's start it in onCreate in the main activity, well, okay, but it's probably not that. Unfortunately, that means it's probably not going to actually get started in all cases. That doesn't really guarantee, like, then the user actually has to open the app for it to start it, and potentially then we have to deal with making sure it doesn't get restarted every time the user returns to the app. Does that make sense? So really where I want to hook this in to run this job is I want to hook it into the application on Create. Is everybody following with me there? The why on that?
Yeah. Yep.
So sometimes your jobs will be started from an activity. Sometimes they'll be started from the application. It depends on what you need to do with them. I would say most periodic jobs, where you say, I want to do something every hour, those are typically going to be always in the application. Whereas one-time jobs can be either place. So what I want to do, I'm going to add a new class in here, and I'm going to call this the primes app. Primes app. Okay, so this is going to be my application class, so I need to say it extends application. And remember, anytime I create an application class, what's one of those things that I have to remember to do?
Add it to the manifest.
Add it to the manifest. Okay. So I'm going to go up to the manifest, and I'm going to say Android.name is .primesApp. And I think I saw this on one of the Prusa readings, but the dot that you're seeing here, same thing with down here. This is basically a shorthand for the package name, right? So I could say edu Ranken PR Smith prime numbers.colong. I could write that whole thing here as that. That would be perfectly fine and would be equivalent. But writing it as dot primesApp is just a shorthand for that, right? Is a shorthand for the package name. So that's what that means. All right, so we've got the primesApp connected in the manifest. And so remember, that's the Android name property. Here I'm going to start implementing the onCreate method. So onCreate, and we want to put our own logic in there. Okay. So let's think about, what we need to do. In order to do things with the WorkManager, first thing I need is the WorkManager itself. So I'll start with that up here, WorkManager equals WorkManager.getInstance. Now you'll notice that there's two getInstance methods, one that doesn't take any arguments and one that takes a context. The one that doesn't take an argument, it's still there. The line through it means it's deprecated. It means that you shouldn't use that. So you can get the WorkManager without an instant, without a context. You really shouldn't. So in here I'm going to pass this as my context. Because applications are a subclass of context. Okay, so that's me getting the WorkManager. Okay, other things we have to do in terms of setting up a job is we have to make a work request. So in here I'm going to create a one-time work request, and this is going to be the find primes request. That's the request I want to open up. And then I actually need to use a builder to build that object. So I'm going to say new one-time work request. One-time work request.builder. So we're going to construct one of those. That then needs a reference to the actual worker class. So I'll give it find primes worker.class. So that's the worker that I want it to run.
The one that I got,
Mm-hmm.
one-time work request, it took no arguments. What's the difference?
You need to call one-time work request.builder.
Oh, all right.
Yeah. So we're constructing a builder. We're not directly constructing the request. And so on that builder, you can set additional things. So we can call set input data to provide some initial data. We can set constraints to put conditions on how it should run. We can also set initial delay of how long should it wait before it starts. There's a bunch of different things you can set on here to initialize it. So here I'm going to set an initial delay, and that initial delay will be 1, time unit seconds. So I'm going to just give it an initial delay of 1 second. So it won't start immediately, it'll start after a second. And then I'm going to say build. All right, so that's going to NQ. Why can I not? That's how I write. So one of the things you have to do is you have to create a request. You can put conditions on there. None of these are required. I don't have to put initial delay on there. Just showing an example. Sometimes you may need one, sometimes you may not. And so once I've got my request, then I can tell the WorkManager to run that request. So I'm going to say WorkManager.enqueue, and we're going to enqueue the find primes request. Okay, so that's going to tell it to run. Now, common thing I will probably want to do here is log the fact that we just enqueued it, so I can come back and debug that. So one of the things I'm going to do, I'm going to go ahead and add a constant at the top, public static final string log tag is equal to prime numbers is what I'm going to use. My tag is the application name. Okay, so prime numbers is my tag, and so down here I'm going to say log.i, use my log tag, and say that find primes has been enqueued. So that way, if things are working correctly, I should be able to see that in the logs. I should be able to see that my task has been started. And in fact, as soon as I start it up, you can see it just filling out the found prime starts going. So just general rule of thumb, it's good to use some logging in here to be able to track what's going on and debug it, because a lot of times you'll have things going on where you can't necessarily see it in the UI. So you may need some logging to see what's actually going on. Okay? Any questions on enqueuing the worker?
Oh, not yet. It's pretty straightforward.
Okay. As I mentioned, one of the things you'll commonly want to do with your workers is you usually will want to give them some constraints. So in here, because the finding primes takes CPU cycles largely, it's mostly just crunching and calculations. One of the things I typically want to check that the battery isn't low, right? So like if the battery is less than 5%, I really don't want this to run because the battery is going to run out very quickly. So in here, I'm going to construct a constraint that is going to prevent this from running if the battery isn't at least partially charged, at least in a good state. So I'm going to call this is constraints. This is going to be find primes constraints. And so again, this is a builder. And so I'm going to say new constraints dot builder. The constructor doesn't take any arguments, but I need to provide then some constraints. So in here, the specific constraint I want to use is set requires battery not low. And so battery not low, true. And then finally I can call build on that. So I can piece into there a bunch of different constraints. Here I'm just saying that I don't want the battery to be low, but just as easily you can put constraints on there to say, hey, they have to be connected to Wi-Fi in order for this task to run, which connected to Wi-Fi is one of the more common ones. But it really depends, as he said in the video, it depends on what is what does that task need to do? What does that worker need to do? So if it needs to connect to the network, obviously it needs network. If it's going to be very CPU intensive, well, then you should check for, the CPU, the battery being there, versus if it needs to save files to the device, say download images and save them, well, it probably needs to check that the storage isn't low so that there's a place to actually put the data once it's been downloaded. So the constraints that you have there will be very much dependent on what you're building. Okay, so take that with a grain of salt. This is going to look very different depending on what application you're building. Okay. Now I've just constructed the constraints. I haven't actually hooked them in. So in the request, I need to also set constraints and give it that constraints object. So by adding this in here, my task will not run if the battery is lower than 5%, roughly. I think 15%. So if I look at Logcat right now, run that, I should see it running. Unless I missed something, which I think I may have. Oh, the other thing you want to do here, notice the way I've set this up. I'm enqueuing it every time the application starts. One of the things that I haven't done in here is I haven't ensured that I haven't made sure that I'm not installing or starting the work, scheduling the request multiple times. So you remember one of the things that he talked about is needing to make sure that your workers are quote unquote unique, right? So I only want one copy of this find primes worker running at any given time, right? Do you remember what we called that if we want to prevent multiple workers from happening at the same time?
Tip of my tongue. I can't think of it right now, though. Deconfliction?
Conflict was in there somewhere. Daniel?
Conflict manager.
Daniel?
I'm sorry, what was the question?
So we want to keep the multiple copies of this worker from running at the same time. Do you remember what was in the lecture about, how to prevent multiple copies of the same thing?
Not exactly. You need to check to see if it's already running.
Okay. Jonathan? Troy? Okay. So remember one of the things that, so may remember the term unique. We need to make sure that this worker is unique. And so we do that by, first of all, we have to give our worker a name. And then we also have to then enqueue it specially. So up here, I'm going to say I want to create a name for the job. So public static final string, and this would be like the maybe job name find primes, and maybe we'll set that as find primes. So I'm going to use that as my name of the job is find primes. Okay, so I'm going to use that down here, and rather than calling enqueue, I'm going to say WorkManager .enqueue unique work. And so enqueue unique work takes 3 different arguments. The first is the name of it. So I'm going to say job name find primes. The next thing I need to pass is that conflict resolution policy, which I think is what you were thinking, Paul. Let me just make sure I got the right name. Existing work policy. That's the one. Existing work policy, and I'm going to say replace. So we're going to replace whatever job was already there. And so we're going to replace that with the find primes request. Which makes this a little bit of a long line, but that's what we need to put in there. So the name of the job, the replace is the second constant, and then find primes request. And so that will keep it from starting up multiple copies of that same job. And that's pretty common. Most of your jobs will need to be unique, and pretty much anything that you start from, the application class should be unique. The one case where it's not going to be unique is potentially if you're starting it from an activity. But if it's starting from a application, it's typically always going to be unique. Now, if I look under logcat, am I seeing anything come out? I'm not sure. Almost looks like my logcat is disconnected. I'm going to close the emulator and reopen it. Oh, no. I don't want the 10-inch tablet. I want the Nexus S. It's looking like it's taking some time to come back up. There it goes finally. Okay. Am I seeing anything in logcat?
I don't have anything in mind either.
Yeah.
Maybe just a coincidence.
Maybe. I think it's entirely possible that we've started enough jobs that it's kind of frozen, I think is the problem. Because remember how he talked about that these jobs go into a database, so it actually remembers these jobs that you queue up long beyond when you actually queue them up. So at this point, there's probably like 3 or 4 or 5 different copies of that same thing in that database because we never canceled them or deleted them. So what I'm going to actually do is I'm going to uninstall the app to clean that up. And
that's the only way to do it, is to uninstall the app physically?
You could potentially call a method to cancel the jobs. Remember how he mentioned that there's a bunch of methods that you can cancel it. So I could say like WorkManager.cancel all work. So that would cancel everything, would be another way I could deal with that, if that's what's going on. But typically you want to avoid doing that. Oh, it was on the wrong emulator. It was on the one that's dead or disconnected. So cancel all work is one way to do that, but the right way to do it is to make sure you're setting it up as unique. Now, I just saw there, that it reached the end of file. I think if I may have to kill that and bring it back up to get it to recur. So one of the things that's happening is that there's an upper limit kind of to what messages can be in logcat. So this is running and spitting out so much to the logs that logcat's actually basically crashing because it's getting overrun by the amount of logging that we're doing. There we go. So logcat, unexpected end of file. This means that either the device shut down, logcat crashed, or yada yada yada. So And this is unable to read the log messages quickly as they're being produced, which is what's happening right now. Is we're shooting out messages so quickly that we can't possibly read them in logcat. The logcat can't possibly process them fast enough. Okay, so the reason that that's happening is because we told it to log every iteration, basically every single prime that we got, we're telling that to log. Does everybody see that?
Yeah, I see that. I can't get mine up and running. I installed it. I'm using the physical device, and
Okay.
I uninstalled it, and now my logcat's completely blank. What
You
should I
will
do?
probably have to unplug and plug the device back in. Like
Okay.
pull the USB cable out and plug it back in to get it to restart.
And then do I need to uninstall, or doesn't matter?
You will want to uninstall because it'll crash again because it's spitting out so quickly. So the way around this is that we want to we need to first of all fix how we're determining things are prime. So the reason that we're getting so much is because we're spitting out for all the numbers from 1 to 1,000,000. So we're trying to spit out 1,000,000 log messages, and it's just going like, I can't handle 1,000,000 log messages. So if I were to reduce this and put in the actual logic in my isPrime function, then this would work, and I wouldn't have to. It wouldn't be crashing all the time. So let's say in my isPrime function, like we want to go implement that. Well, I want to implement that starting as maybe I is equal to 2. I is less than whatever the number is, plus I. So we'll loop through all those, and if number is divisible by I, okay, then we know I is a factor, and that would mean that this is not prime. So I can return false. If we get all the way to the end, then I'm going to return true, saying that yes, this is a prime because we didn't find anything that divided into it. So if I do that, rerun it, it's still crashed. So that's where like you need to either unplug the physical device or restart the emulator so that it can reopen that connection to logcat. There we go. And so because we're only spitting it out for primes, it probably won't, it shouldn't crash at this point. Because there's not 1,000,000 primes, there's quite a bit less than that. All right. Does everybody have the same thing happening now? Where it's logging to logcat, but only logging prime numbers. Cool. So we haven't put any sort of UI on it yet. One of the things that we had done, remember, is we put a constraint on that to say that it should only run when the battery's low, when the battery's not low. So if I were to go into here and let's just change the battery to be 0%. Okay, well, something happened. And you'll notice here that it said something about the task was canceled as being output, right? So because of that, that caused the task to be canceled, the work to be canceled. Close some other tabs that I have open here. So we can kind of see that, and we may want to put some log in there to see, what happens, what is happening here with tasks being canceled. So in here, I'm going to point the maybe job done. We would say log.i, and I actually want to use the same log tag that I have created previously. So I'm going to use primesApp.logTag. So for this app, I'm going to use the same log tag in all my classes. So primesApp.logTag, and I would say, what message do I want to output? maybe I say found all primes up to max. And otherwise, I might say worker was canceled at whatever the current number is, right? And just like I changed these to point to the primes app.log tag, I'm going to change the same thing here.
Was that log tag public?
Yes, I did make it public, so I can
okay.
access it
All right.
elsewhere. And other thing I might want to log when it starts, right? So I might want to log when it starts finding finding primes. Oh, this is current. Not current. So that should give me some logging for when it starts and when it finishes, or if it gets canceled. So that way I can see things going on. And I can narrow this down. So prime numbers. So I only need to watch for my tag now. So if I, right now the battery's at 0%, right? So my task hasn't started because the constraints haven't been met. As soon as the battery gets up to a good point, so let's say I get up to 40, you can see that the task now automatically started itself. So it actually waits until the battery's in a good state, because I said wait until it's not low, and then it will start it immediately. And then if I stop it, pull it down there, okay, so the worker was canceled, and we can see it was canceled at that number. Does it kind of make sense? Helpful tools, logging. So oftentimes it's very helpful to know, when did your worker start, when did it stop, and under what conditions did it start or stop. All right. Any questions about this so far?
Yeah, it looks pretty straightforward.
Okay.
Easier.
Yeah, I mean, I will say overall, it's a little bit intimidating getting into WorkManager. There's a lot of new stuff to learn. It really is ridiculously easy, especially for all the stuff you can do with it. I'd say it's a very easy system to use and learn, especially compared to all the other things that we used to use to do the same thing. This is so much easier. So, things that we used to have to do, we talked about broadcasts. One of the things we used to have to do to make this very system work is we'd have to use a broadcast to listen for when the battery's not low. And we'd have to build that in every application we want to do it in. So, just putting these constraints in gets you around needing to use a broadcast receiver to listen for the battery. So that's great. Same thing for network connectivity. Network connectivity is about as simple as this. You just call a different method. So that's kind of the starter point of getting all that set up. Okay. So the next question is going to be, so we've got, this is running, and it's running in the background. And it's spitting out data to the logs, but that's not really useful to my user because they can't see those log messages, right? So I need some way to communicate the data from the worker to the UI. Okay, I need some tool to communicate the data from the worker to the UI. So just tossing this out there. what are some tools, what are some things that we've learned about that you might be able to use to facilitate that communication?
How about a progress bar?
Okay. So a progress bar would be a good thing. Yeah. But how do I get the data from the worker to the activity, right? Because the activity is the one that's going to have to update that progress bar. So while people are thinking about that, I'm going to go, let's go and spec out the layout, and we'll kind of think about that as we do it. So going to activity main layout, let's put a few things in. So I'm going to first of all delete the text view that's there. We won't need that. And I want to think about, well, what do I want to show? Okay. So things I might want to do, maybe I'll put in a text view here. Maybe I'll put in a progress bar. Let's actually put in both kinds of progress bar. I'll put in a bar, and I'll also put in the circle. So this one will tell us, is it, how far along the way is it? And this one will say whether or not, yes or no, is it running. And then maybe here in the text view, we can show like what's the highest prime that we found so far. So that gives a user a few different ways to see what's going on. I'll go ahead and turn on my system UI so I can see that, and then start anchoring it to the top left corner. Here, 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 here. And I'm actually going to leave both of those at a margin of 0 because I'm going to actually use padding for this example rather than margin. Another thing I might want to do, I probably want to show a list of all the primes we found. So I'm going to add in a recycler view as well. Anchor that to the bottom left to the frame, except for on the top, I want to anchor that underneath the progress bar. Now you'll notice that the recycler view is still up full screen. That's because it's set to match parent initially, so I need to just change the width and height of both of those to match parent. In terms of positioning this circular progress bar, I'm just going to anchor that to the edges of the screen. So it'll be centered on screen. There we go.
The recycler view's top is to the bottom of one of the text views. Is that
yes, is the bottom of bottom of the progress bar. Bottom of the progress bar. And the top progress bar here, the horizontal one, I want to set the width of that to match constraint, and the width of this also to match constraint. You should have something like that.
Hey, can you save me a lot of time and just copy and paste the XML over there? So I need to set it all. I'm way off here.
Yeah, let me put the IDs in first before I do that.
Okay.
So, in the IDs, so this would be the highest, or maybe I'll call this prime, highest, and this would be prime, progress, horizontal, and this would be prime, progress, circle, And maybe I'll just keep that as, well, prime. I'll put that as prime list. There we go. Okay. So I'm gonna, yeah, I can grab the code now.
Yeah, I appreciate that. I find that coding along, for me, I don't know about everybody else, but this is like the most tedious part.
Yeah.
I always fall behind.
There you go.
Yeah, thanks.
I didn't snip the constraint layout part on the outside. That's just the stuff inside the constraint layout.
Yeah, that's cool.
So, because that tends to be a little bit different depending on your setup. So, all right. So we've got that.
What happened? Am I missing your prime list? Oh, there it is.
Yeah.
Was it just not? Okay, never mind.
Yeah. So we got a recycler view to put some, the list of numbers as we get them in. We've got that. I think the text view here, I do need to fix that real quick so that the text shows maybe nothing there. Maybe I will have that as highest. Yeah, so just some placeholder text for that. Now with the two things on the top, the text view here and the progress bar, I want to give both of those a padding of 8 dp to separate them from the edges. There we go. So that turns out to be, in this case, it's just a lot easier to set up that spacing as padding instead of setting it up as margin. But you can do it either way. Okay. Is everybody caught up with that on the layout side of things?
Yeah.
Okay. All right. So that's our layout. We want to now start connecting the activity to that. So I'm going to go into main activity. And in here we need, let's see, well, what views do we have? So views, I need private, text view. This would be highest. And private progress bar, and this would be like the horizontal progress bar. Private progress bar, this would be the circle progress. And finally, I have a recycler view. So recycler view, I'm just going to call that one recycler view. Okay, so I've got a few different things that I can reference there. We need to now find the views. And so highest text is equal to find view by ID, r.id dot prime highest. The horizontal progress is find view by ID, r.id dot progress horizontal, and the circle progress is find view by ID, r.id, and that's my progress circle. The recycler view finally Okay, so I've got a few different views that I've connected up to that I now can kind of manipulate as we get data. So one of the questions that I asked before we started setting up the layout again was how can we do the communication between the worker and the activity? So there's one tool that we talked about, and I think we talked about it on Friday, which might be useful here, right? You remember what we talked about on Friday?
No. I mean, it's a long time ago.
Okay. This is just last week.
I know. That's a long time in coding.
Okay. What were the topics that we covered last week?
Async tasks.
Async tasks, and we covered one other thing. Remember you did a lab with the headset jack? Do you remember what you used for that?
Oh, receivers.
Broadcast receivers, right? We talked about broadcast receivers on Friday, remember? And so remember I talked about the fact that there's like 3 different kinds of broadcasts. There are system broadcasts, there are application broadcasts, and there are local broadcasts. And so specifically in there, remember local broadcasts are used to communicate between different parts of your app. So for instance, one place those get used is you can communicate between services and activities. They also function as a potential mechanism to communicate between workers and your activities, right? So if the worker needs to tell the activity about something that's going on, it can't.
Okay.
That was my cat. I don't know what the cat jumped about.
Did you get that fire put out?
I don't know. He saw something. I don't know if he saw a bug or what did he see, but anyway, he jumped. So the one way to communicate between workers and your activities is to use local broadcasts. And the nice thing about that is that there's no connection. So even if the activity is no longer running or not visible, then the broadcasters get ignored, but they still get fired. So you don't get into issues where you have to worry about whether or not your activity is created or destroyed or what life cycle state it's in. That kind of, you get some built-in work with that. Unfortunately, that does mean potentially you're sending out broadcasts when nobody's listening, right? Is one downside. But it does create a situation where they're not tightly bound together. Because you can't and you never should try to create a system where you have a reference to an activity within a worker. Does that follow? Other things you don't want to do, static variables, no. You don't want to use static variables to communicate. But local broadcast is one way to do that. So to set up a local broadcast, the first thing I need to do in the worker is I need to actually get a reference to the local broadcast manager. So in here, I'm going to add private. Actually, maybe I'll add it at the end here. I'm going to add private local broadcast manager. And this will be the local broadcast manager is the name of that variable. Local broadcast manager is equal to local broadcast manager dot get instance, and I need to pass it in the context here. So now you'll notice I actually do need to do this work in the constructor because down in do work I don't really have a reference necessarily to a context. So I have to do it up here while I have that reference. So now I've got the local broadcast manager. When we get down here, we can then send broadcasts where we're interested in sending those things. So places where I might want to send an event, there's actually 4 different events I might want to send here. I might want to say, okay, let's broadcast when it starts. We'll broadcast every primary find. We'll broadcast when it stops. And so maybe we broadcast when it stops regardless of whether it was canceled or resumed. I could make those two separate broadcasts, but I'm going to keep that as the same. Okay, so start, found, and stopped. And I'm going to clear some constants. I'm going to clear those in the application class so that I can use them easily, access them in different classes. So in here I'm going to say public static final, and I'm going to clear those different broadcasts, those different actions that can occur. So in here I'm going to say string action, and this may be find primes start, and find primes start. And so I want one for starts, found, and stopped. Prime found, and action find primes stop. So maybe this one is prime found, find primes stop. Maybe I'll rearrange those a little bit to put stop and start next to each other. And that should be found. So I've got 3 different actions that I can send out and I can receive. Any questions there? Those are not a given as far as, should you always have a start stop and other things? Not necessarily. You should really just build it based on what you need, right? So in here it will be helpful for me to know when those things occur, but the interesting events for you will probably be something different depending on what you're building.
So these public static final strings, these generally are best placed at the high level app, right?
Yeah, application is a good place to store these. If you need to access them from different classes, that's an easy place to put them.
Okay.
That way you're not, like your activity isn't tightly linked to your worker. They just kind of have, hey, there's a string I know is used in different places. So that's what I'm going to do. Not everybody puts their constants there, and that's okay. There's a bunch of different ways to approach that problem. So, first thing I want to do is I want to send out a broadcast at the beginning when it starts. So I'm going to create a new intent here. And so intent is equal to new intent. And this would be primes app dot action find prime start. And in there I also want to add maybe some data. So I might want to add in for instance, maybe what the current value and the max value are. So I might want to add those as additional constants up here. So like public static final string extra current is current, and public static final string extra max. And so there we go. Okay. So I'm going to have the current and the max, and so those are all the constants that I'm declaring in there. So I need some, the actions. I will also need the extras. So coming back here, anytime.
Is there a reason your intent is surrounded by curly brackets? Or is it...
The one reason, you don't have to do that. The reason I'm doing that is so that it creates a small local scope. Remember, anytime you have curly braces, that creates a scope for your variables. So that means that this variable here, the intent, will go out of scope when I leave the curly brace. So I'm just scoping this variable. That's all I'm doing.
Okay.
So in here, I want to say put extra. And so we're going to put extra the primezap dot extra the current. So I'm going to list what the current value is. And I'm going to list the max value as well. So that we can send those through. And then local broadcast receiver dot send broadcast, and I'm going to send that intent. The reason I wanted to scope that in there is I don't want to accidentally use the same object or use the same variable later on where I'm sending other intents. So that makes sure I can have local objects for everywhere I'm going to send these different intents.
Otherwise, you might like have to put something like intent to or something that's lame, right? You want it keeps you using that same name. That's it.
Right.
That's really it. Otherwise, you don't need it.
Yeah, and it also keeps me safely from accidentally, accidentally leaking different things, like leaking some extras from one place to another. So this would be prime found, and I'm going to pass in both of those values, the extra and the current. And here we're going to also, same thing here, when it finishes, I'm going to say dot action prime stop. Now in here, just for safety reasons, I'm going to send the max as both the current and the max, and that way it doesn't send it as like the max plus 1, which is be what it would send it otherwise. So I'm just going to send that as both. Actually, I want to move my comment back down to where it was meant to be, which was with the return. So this would be action prime stop. Great. So when we start it, we'll say it started. Every time we find a prime, we're going to send out a broadcast there. And then when we stop, we'll send out a broadcast with that information as well. Actually, I probably want to rewind that and just use the current here, regardless of whether or not it's that. So current max. Any questions on sending out this broadcast?
No.
Would it be considered bad practice to send broadcasts that quickly? Because we're going through a lot of numbers here.
Yes, this is more broadcasts than you usually send. This is usually more broadcasts than we send typically. In this case, it'll work just fine. But you're right. Yeah, usually we send them less frequently. But my testing with this before we started is that it worked for me, even sending this many broadcasts.
Okay.
So, yeah, it's more than you usually want to send, but in this case, it's going to work out. So one of the things we'll talk about, there is another way to deal with this so that you don't send broadcasts. There's a different communication channel that you can use called live data. We'll probably talk about that tomorrow because we're running low on time. So tomorrow I'll talk about how to do this with live data instead of broadcasts. So that's another way to reduce, to send the data differently. But I need to, effectively, I do need to send, with the way this program is, I need to send every prime that I get. Otherwise, we're going to lose the primes. Okay. So I'm going to go back to, and by the way, I'm actually going to comment out that line here. So that's not logging every time. I'm going to go back to main activity. And so now we can start hooking some logic to that. I just like I was doing on the worker, I need a local broadcasters, the local broadcast manager here as well, and I need a receiver, broadcast receiver. And so I'm going to call that receiver, and I also need an intent filter. Call that intent filter. Okay, a few different things I need to hook up. So create receiver. And so in here I'm going to say receiver is equal to a new broadcast receiver. Okay. And so then I need to tell it to do different things based on the action we get. But I'm going to put a pin in that for a minute. I need to create my intent filter, which tells me which actions am I interested in listening to. So intent filter, or sorry, nope. I've already got an instance variable, so I just need to say intent filter is equal to new intent filter. And to that intent filter, we'll add the 3 different actions that we want. So add action, primes app, dot, find prime start, intent filter, dot add action, primes app, dot action stop, and we also want to know when a prime is found. Okay, so we're going to update the UI anytime those things happen.
Mr. Smith, can you explain? We haven't used intent filter explicitly like this. What is that doing again? So it's just looking for all the responses there that come from the find primes worker and then doing something in accordance with that. Yeah.
It doesn't do anything yet.
Okay.
What
will it do?
What it will do is what I'm going to do is I'm going to say the receiver gets notified of those 3 different broadcasts. Is what I'm going to use it for. So an intent filter, we did cover this on Friday.
Yeah, I know. It's easy to forget though.
So what I want to do is I'm going to say when this starts, when this gets created, I need to then register the receiver. And that's what tells it to start listening. So in here I'm going to say local broadcast manager dot register receiver, and then we'll provide it both the receiver and the intent filter, right? So without this line of code, the intent filter does nothing. It's just an object. This is what does the interesting bit, is registering the receiver. So when you register the receiver, I'm saying I want to hear those 3 actions, those 3 broadcasts. And if it's anything else, then don't tell me about it. Only tell me about those 3 broadcasts. Also in here, I'm going to override on destroy. And so when it gets destroyed, we need to unregister our receiver. I could also do that in on stop or on start. Those are options as well. But I'm going to start with this. Okay. Any questions on that, or is anybody still typing?
I think I'm all caught up.
All right, so let's think about what we're going to do when we do get those broadcasts. So in here, I want to put a switch statement, and so we're going to switch on the action. Intent dot get action. So based on what action we get, should influence what we do. So in here, if I say, well, okay, so it is the primes app dot start. So if it's a start event, then we want to do one thing. If it's the stop event, then I may want to do something else. And if it is the found event, then I'm going to do a third thing. Okay, so I'm doing a different thing based on what occurs. So one of the things I probably want to do when it starts is I want to actually show the circle progress bar. So for instance, in here, I'm going to say circle progress dot set visible, set visibility, and we would set that to view dot visible. So we're going to make the circle progress visible when you start it, and then I probably want to hide that when it stops. Set visibility view dot gone. So we'll make it visible here when it starts, and then when it stops, we'll make it go away. So we can kind of see that note to know, is it working or not working. On a similar note, while it's working, we'll keep getting these prime found events, so we need to make the circle progress visible. So, because it's still in the process of working. As we're going through, we also would like to update the horizontal progress bar. So in terms of that, I want to calculate how far along it is. So we want to say set progress. And so there we just need to calculate what part is it, how far is it through the calculations. Okay. So here I need some calculation, and it's going to be basically 100 times the current divided by the max. You know, that would give us the percentage that we're at. Now you remember that both of those values we've passed through as extras on the intent. So I do need to extract that from there. So maybe up here I'll say intent, I'll say long. Actually, no, I'm going to do this differently because I want to make sure you know how to do this. So I'm going to say long current is equal to intent dot get extra. So I'm going to say get long extra, and here this is primes app dot extra current, and maybe we default that value to 0. Long max is equal to intent dot get long extra. And so this would be primes app dot extra max 0. So I get those two values out of the extras. Now, when it stops, I need to do the same logic. So I need to say, let's get the current to the max, and we'll update the progress bar using the same calculation. Now, if I do that, you'll notice here that there's a red squiggly under the current and the max. Does everybody see that?
Yeah, I didn't get that. It's not red for me. Why is it red?
Well, it should be red for you. If it's not red, then you're missing something. So here it says variable current is already defined in the scope, right? So it's saying that we have already declared that variable. You can't declare it again. So one of the things to watch out for with switch statements, notice that the current here and the current there are in the same scope. Is everybody with me there?
Are you going to put brackets around them like you did before?
Yes, that's the fix. If you just put brackets around each of these cases, now they can have their own scopes. So you remember I kind of introduced a set of curly braces back in the worker to do the similar kind of thing. Oftentimes you find that you just need curly braces like this to create another scope. And what did I get wrong? Because that is all. Okay. It's just saying that this is the same as that. Okay. Merge with prime start. Yeah. That's fine. Because the found case and the start case are the same. The same code. Although actually, let me undo, because they are the same code right now, but they're not going to be in a minute. Those are not the same case, because I need to do something else that I haven't done. Prime numbers code along keeps stopping. So why did we crash? Local broadcast manager on a null object for reference. Oh, because I didn't get the broadcast manager. So local broadcast manager is local broadcast manager dot get instance this. There we go. Okay, so now you can see the progress bar spinning. You can slowly see the progress bar incrementing. I also want to show the current number there, which is what I didn't do. So in here I'm going to say highest text dot set text, and we're going to do a string dot value of and take the current. There we go. Okay. Any questions? You can see we've kind of offloaded the work off to another thread. And one of the things I can do now that we maybe couldn't do previously, if I go out of here and I'm just out on the desktop for a little while, out on the home screen, maybe using another app, come back, we'll see that it's been working while I was gone, right? So that's, part of what can happen using this WorkManager system is that it can be working while you're using other apps. So downloading files or images or uploading, all sorts of things while you're using other applications. Any questions?
Not quite working right. I'm not getting
Okay.
some of the displays. I'm sure I'm just missing something in the code.
Okay.
Oh, yeah. But the progress bar is working and the log cat's working. Just yeah, I don't know what it is.
What are you not seeing? Or are you not seeing the text, or are you not seeing the spinner?
The circular spinner is like, I don't know, for lack of better words, I'll call it twinkling, and then there's no text.
There's no text. So you remember I added this one line to make the text work.
I did that. I did that. Yeah.
Okay. It may be a case of where your layout set up then. Possibly. Might be a layout problem.
Okay, I'll take a look at it. Yeah. So how do you cancel? Is it just by changing the orientation that'll cause it to cancel?
It actually doesn't cancel. Let's just try turning that real quick, because that's interesting. See how it keeps going.
Yeah.
Because the WorkManager, remember, is doing work in the background. So if I turn it sideways, that creates and destroys the activity, but it doesn't stop the worker. Does that make sense? It doesn't stop the worker, because the worker is completely separate from the activity. So like that was one of those things, like that specific case is why like async, the async loader is meant to handle that one specific case. Look, we've solved it. We hadn't used async loader. So. Okay. Things we haven't gotten to today. I want to talk about how to use live data to send the data, to send things through, to update the UI, as an alternative to using broadcasts, because oftentimes those are a little bit of a better tool in your bucket, which is a new thing. It falls under the architecture components, just like the WorkManager, and you may have heard live data mentioned a few times in the slides. So I want to look at that tomorrow when we finish this up. I also want to look at filling out the recycler view right now, because the recycler view we didn't get to doing anything with. So those are the two things to do tomorrow morning, and then we'll talk about an example with downloading, or tomorrow for class, and then we'll talk about downloading files and such. Cool.
Yeah, sounds good.
So, there's not a lab assignment right now. I just want to do some, do some in-class examples to kind of get you prepped and give you the tools before I set you loose on making your own thing with it. So you have kind of the context to work with. So, all right. I will see you tomorrow.
Okay, Mr. Smith, can you take a look and see what I'm doing wrong here?
Yeah, I can.
Yeah, sure. I'll have to, of course, run the emulator, but.
Sorry, I'm running a little bit behind on my end. Trying to figure out this code example, which has turned out to be a little bit more complicated than I originally realized. So, let's see. We were working with that Find Primes app, I believe, yesterday. So let me close this if I can. Where is it still running? Okay. So, let's see. So what were the things? Why is my device crashing? Okay. So I think there were two things we needed to talk about still yesterday. One was getting things into the recycler view, and the other thing was talking about live data, I believe, is where we stopped. Let me go to my killed this. Restart it hard. Okay, so kind of thinking about that, as far as we set it up yesterday, we're kind of showing some of the data. We put some progress bars in place, different ways to display the data as it's occurring, but you don't really have a list of all the primes we found, which is kind of a common thing that you'll run into is you need to show a list of data as you're working through these different things. Right, so if we're thinking about the data we need to show, right, probably the first thing to start with is to start with adding in a layout for that item, right? So maybe under layout, I would go new layout resource file here, and I would call this maybe item underscore number, right? So I'm going to be showing a list of numbers. So that's what I want there. Okay. Now, my layout's pretty simple. Realistically, all I need to have in that list of numbers is just a single text view for each item, right? So oftentimes I would just kind of drag it in here, toss in a text view inside of here if I need to display more than one thing. But sometimes you get to places where it's like, well, I only need to have a single control here. Does that make sense? Like, I only need to have a single control. So, I mean, options are you could actually just create that control in code, and sometimes people do that. I tend to go ahead and use a layout anyway because I feel like it still future-proofs me. But what I will do instead, rather than adding a text view here inside of the constraint layout, because in this space we really don't even need that constraint layout. What I'm actually going to do is convert this to a text view. So I can go ahead and switch this over to just be a text view tag. Width would still be match parent. I want to change the height to wrap content. And then if I wanted to have some text to show up in there, at least for the designer, I might want to add that in too. So here I might say number, right? So just by putting in a few things there, then I can get that layout. I can get the thing for a layout for the numbers, but really, in this case, it's just as simple as just having a single text view there. One other thing I might want to do in here is set some padding. So I might want to say padding of 8 dp. So I got a little bit of spacing there. So I'm going to just send that off. And actually, I don't even need this end tag because I can just close it out like that. So oftentimes, if you need just a very simple layout, single text view, that's oftentimes how I set that up. Questions? It's very quiet in here.
Yeah, I'm still finishing copying it over real fast.
Yeah, I went ahead and tossed that over into Discord for everybody who wants to just bring it in. But that's how I finagle that. If I just need a single text view or a single control, that's a little bit more efficient than wrapping in a layout. Obviously, if you have more than one control, or that in the future that might change, then it's worth having the layout there to make it easier to change later. But if you have cases like this where it's like, well, I don't need the overhead of a constraint layout, it doesn't make sense to have a layout container there when you won't need it.
Did that file start off as a recycler view? How did I saw you change it, but I didn't see what it originally was.
It started out as a constraint layout, right? Anytime I create a brand new layout, it's going to put constraint layout there as the root tag.
Okay. Got it.
Right. So I've replaced the constraint layout. I converted it over to just a text view. Okay. So now we can actually start to hook things up. In this case, I really don't need to add anything to my model right now because we're just dealing with numbers, and so numbers already have their own data type. You know, I've already got the long class, so I don't really need to create my own model for this particular program. But I do need to create an adapter and a view holder for this data. So first things first, let's go ahead and create the view holder. So this is going to be the number view holder. Add. And remember that this needs to extend the recycler view holder class. In terms of what we need in here, I'll enter to implement that constructor. But in terms of what we need in here, we just need a single reference to that text view. Which could be something like that. All right, so that's all there is to my my view holder. Not much. Just a holder for that text view. And then we can get on to the adapter. So I'm going to make a number list adapter add. And so this is just going to have in it a private list of longs, and this is going to be my items. I need a reference to the context, so go ahead and add that context, and my layout inflator. So private layout inflator. Okay, so add those three properties. And then let's mark this that it extends the recycler view dot adapter, and so this is going to be the number view holder is what we want in there. Okay. Now we can start implementing our constructors and our other method. So public number list adapter, and so that's going to take a context and a list of numbers. And so in here we can say this dot items is equal to items. This dot context is the context, and this dot layout inflator is equal to layout inflator dot from context. So we have the three parts that we need for a constructor as usual. I'm also going to go in add in here a way to set the list because that often becomes necessary to update things. So public void set items, and that's going to take a list of logs. And so in there we just say this dot items is equal to items and notify data set changed. And the important thing here is basically adding that method allows us to put new data in there without recreating the adapter, without creating a brand new adapter. So that's why I'm adding that there. And then the next thing to do is we need to implement the various methods. So get item count. If we do have a list of items, then we want to return the length. But we need to make sure that we're actually checking that it is null. So if it's not null, we can go ahead and just say items.size. But if we have a null list, then we're going to say, hey, there's nothing to show. Next up would be the onCreate view holder. And so internally to that, we remember need to inflate the layout first. So view item view is equal to layout inflator dot inflate, and so we're going to use our number layout, or dot layout dot item number. We're going to pass the parent and false as always. Other things we need to do, we need to construct the view holder. So number view holder VH is equal to a new number view holder. Pass in the item view that we inflated. And in terms of setting the layout, now I need to set that text view. But this case is a little bit different because I didn't nest my text view inside of a layout. This item view is actually the text view. So I just need to cast it to cast the item view to a text view to make this work. Now it looks like I didn't mark my text view as public, so that seems to be the problem. Yep. So I need to go back and mark this. In the view holder, I need to mark that as public. And then finally, at the end, remember to return the view holder. So normally we would say find view by ID, and that works as when you have multiple controls, which is kind of the norm. But if you just have one control that's there at the root, then the thing that you inflated is actually that thing.
On line 34,
Yep.
Why do I remember that returning 0? I don't have other code in front of me.
Because I mistyped. That should be 0.
Okay.
I mistyped. That should be 0, not null.
What's the thing that the red line on line 16? What is that looking for? I can't remember what makes that go away.
On line 16, because we haven't implemented all the methods yet. So remember, we have to implement get item count on create view holder and on bind view holder. Once you implement all three of those methods, then it goes away. Because remember,
You mean use them?
No, implement them. Remember that your adapter, the base class, is an abstract class, right? So get item count is abstract, on create view holder is abstract, and on bind is also abstract. So you need to implement all three of those in order for that to go away, because they're abstract. Okay?
I think I get it. I mean, I just know we use that elsewhere, and it just through the course of doing it, it goes away. But I never paid attention to when that actually happens.
Yeah, it goes away once you implement all three of those methods. And I can go up, I'll enter, basically the hint it's giving me is implement the methods or make it abstract. If I make it abstract, then I don't have to implement all those methods, but then I can't do what I need to do with it. But here I want to implement those methods. Now I usually do that one by one because I want to have them in a particular order, whereas because I think this order makes a lot more sense logically. If you just do the auto-generated, then it just puts them in alphabetical order, which really doesn't make a lot of sense as you're reading through the code. So that's why I usually do it that way. Okay, so we're gonna in here on bind view holder, and I want to say when we get when we need to find the number that we're looking at first. So long number is equal to items dot get, and so we're going to get the position, the item there at that position, and then I just need to update the text in the view holder, ph.textView.set text, and we're going to set that to number dot toString. And I can just call toString on that here because it's an uppercase L long. It's already an object. Questions?
That's pretty routine stuff so far. We've seen it already.
Yeah, just putting our foundation in. So, all right. So we've got our adapter, we've got our view holder, we've got those kind of things bound up. Now I can actually get the recycler view in. So I need to go back to activity main. Oh no, I did already add the recycler view. I was thinking we didn't add the recycler view yesterday, but we did actually add it to main. So I can go directly to main activity and start putting in the code. So one of the things I know, I'll want to have a reference to the list as I'm going. So list long, and so this is going to be the primes, and I'm going to have a adapter, a number list adapter, and I'm just going to call that adapter. So you need to add both of those as fields, both a reference for both the list for our primes as well as an adapter for that list. And then we can go and set up the recycler view. So initialize the recycler view here at the end of onCreate. So remember, first things I need to do, I've got that list. I do want to go ahead and start creating a new list here, a new array list. So we're going to start with an empty list. We're going to start with an adapter that wraps that list. So new number list adapter. We're going to provide this as the context, and we're going to provide primes as our list that we're using. Next up, I want to actually configure the recycler view here with the layout manager. So I'm going to say set layout manager, and we want a new linear layout manager. And so we're going to set that as context. Now remember, there's a few different ways to configure that layout manager. The linear layout manager can be either vertical or horizontal. In this case, I think, as usual, vertical makes more sense. But there's actually a third flag I can put in there to make things appear backwards. It's called reversing the layout, which actually here makes a lot of sense. So that would mean that the newer primes that we get, newer values we get, end up on the top instead of ending up on the bottom. So that's one thing I'm going to do here, is I'm going to flip it upside down. So if I say this, and then linear layout manager dot vertical, comma, true. So true is saying that we do want to reverse this layout. So rather than it going from top to bottom, it's going to go from bottom to top. Which means the new items appear at the top of the list instead of appearing at the bottom of the list. And so I also need to set the adapter, and I'm just going to do that with set adapter. So that's enough to just initialize the connection between our list and our adapter and our recycler view. So, there's a connection there. Now, what that doesn't do is actually add things to the list, right? So if I were to run the application right now, I would still find that my recycler view is always empty because I haven't put anything in to populate that recycler view. So under what condition do we want to populate that? We want to populate it every time we find a prime. Okay. Now, if you remember from yesterday, the place that we find out that we got a new prime is up here in our broadcast receiver, right? So when we find a prime, then we're going to trigger this this case action prime found. You're going to receive that broadcast. That's the point where we need to add it to the list, right? So if I want to take my prime, add it to the list, I just really need to add 2 lines in here. So it's going to be primes dot add, and so let's say we add the current because that's the prime we just found. And I also want to then tell the adapter that there's been a change. So I'm going to say notify dataset changed. So those 2 things put together, it's going to put it in the list and tell the recycler view that there's a change. Okay, our data showing up, and you can see it's reversed. So the lowest numbers at the bottom and the higher numbers are at the top. But you'll notice that it's not automatically scrolling to it. Okay, everybody see that?
Yep.
Yeah.
So that's one of the things I want to do in this case, is I want it to scroll always to the most recent one that we added. Now, because it's reversed, at least my intuition would say, I want to go to the top of the list, so the top of the list is index 0, right? And let's try that real quick to see what happens if I say scroll to index 0. So recycler view dot scroll to position. If I scroll to 0, it should be scrolling to the top of the list. Problem is,
but you're loading the list backwards,
right,
not
so,
adding at the beginning of the list, so it would still
right.
going to scroll the end of the list.
Yeah, so it's still scrolling. It's still scrolling down to here, to the beginning of the list. So even though it's now at the top, I still have to go by the index there, which would be primes dot size minus 1 is the index of the last one we added. So if we do that, now it's scrolling up to the top. So that's not always something you want to do. You don't always want to necessarily scroll to the new data, but oftentimes it can be a useful thing to have, at least in your tool belt, because it is sometimes something you need to do. Any questions?
No.
Can scroll down slightly in the code. Yes.
Does the circular progress bar, does that do anything other than just turn while it's waiting, or does it show like a 0 to 100% type thing too?
Nope. That's all it does. It's just a true or false. Is it doing something or not doing something? That's all it's intended for. And one thing we can do, this is taking some time to get to the end. One of the things we can do is just go back to the worker. And remember, I previously had hard-coded the max in as 1,000,000. If I were to just yoink this down to maybe 100,000, it should finish much more quickly. So we can check that it's working when it's done. Now you'll see a little bit of jitter in the way the progress bar moves. That's because prime numbers are not evenly distributed, so we're not sending at a consistent interval. But you can see there. So okay, it gets done. We hide the progress. And if I were to maybe leave this app, go do something else, maybe go browse the internet or Facebook or whatever, I could come back later and we would see, that our data is still here, right? So it's because it's done that in the background, or it might even have finished it while we were doing something else. So that's part of what we're trying to get to is, how can you do things where you're doing work in the background that can be deferred or done when certain conditions are met, in this case, the battery not being low, and being done even potentially when your app's not running. So this is one way to do that. All right. Any questions on this example at this point?
Not yet.
Okay. So that concludes at least the first version of this. So what I want to do, one of the things that, what we're using here for the communication back and forth is a local broadcast manager. And that's a good tool to have in your belt. That's good for events. If you need to say, when something happens, do this. Broadcasts are really one of the better tools for that. But there's also additional tools that you can use to potentially pass state back and forth between the different sides. So another tool that you can use is something called live data. It's part of the architecture components, just like the WorkManager is part of the architecture components. So it's a common thing we use. Now, this is going to change the application quite a bit to the point where I want to save what we have here and make another version. So what I'm going to do is I'm going to go ahead and commit my changes here and go ahead and commit and push that. And then I'm actually going to close Android Studio here. I'm going to say exit. And I'm actually going to go to that folder. So we'd called that prime numbers code along. I'm going to make a copy of that, and that copy is going to be named code along 2. So we'll just finish up the first one. We'll now do a second version of this. So we're going to retain a lot of the code, but enough is going to be changed that I want you to kind of see and be able to compare the two, the before and after. So as you get that copy made, go ahead and open it up. And I'm just going to wait here until people have that copied and opened. So, as I said, local broadcast is one way to send the data over. The other way that we can do this, which is kind of it's a newer approach to do some of these things. And you may have, I think in the talks that we saw yesterday, we saw some hints to it. So we saw some hints to like how do we do that in terms of, you heard the term recycler, not recycler view. You heard the term live data a few times in the talks that we watched yesterday, which kind of points to the fact that this is a really big thing. It's, as far as where that's actually, live data is actually covered all the way in lesson 10 of this particular textbook. And it's buried in a bunch of other topics that I feel like it kind of gets lost, especially in the fact that you can actually use live data without all of the other stuff connected to it, at least that come up in lesson 10. So I want to show you how to do this, because I think that understanding and using live data is something you can definitely do without all the other dependencies that are sometimes tacked onto it. So looking at the model basically is where we need to start. So under model, I'm going to say I'm going to create a new Java class, and so that class is going to be named primes data source. And so basically what we're going to do is we're going to use that as a communication method or communication pathway between basically the front and the back end, is this primes data source. Now, one of the things that's worth noting, if I run the application as is right now, go get it running. And one thing I want to point out, if I push the battery down to say 0%, right? So that kills our task because we told our task should only run when there's sufficient amounts of battery. If I then push this back up, one of the things you'll see is that the task restarts actually from the beginning. So it skips all the way back and starts over, right? So it doesn't actually remember the work that it's already done. So every time it does this, it's going to start over. And you can kind of play around with that, with trying to figure out a centralized store of basically what your progress is. But I think that my feeling on there is that was a lot harder for me to figure out a solution with broadcasts. Where on the other hand, doing this with live data and doing, tracking what progress was, I found actually was a lot easier to implement in that sense. So thinking about the state of our application, right? What are the important bits of information that we need to track the state at any given time? What bits of data do we need to track the state of this program at any given time?
The most recently found prime.
Okay, so the most recently found prime, which I would actually be a little bit more general, and we would say maybe the current number, right? The current number that we're looking at, whether it's prime or not. Does that make sense?
Yeah.
Basically, where are you in the loop, right? And on the same token, we need to know how far are we going to go. So I'm going to say, where are we currently? What number are we currently looking at and inspecting? What's the maximum number that we're going to check? Okay, so if we have those pieces of information, that tells us a lot. And then we also need a way to track the numbers that we've found, the primes that we've already found. So if I add in here an array list of longs, these are our primes, right? So basically at any given point in time, if we have this data, right, that's all the data that we need to display the front end, right? So that's the data that we need to communicate between the worker thread and the foreground. Everybody with me there? That may change depending on what you're doing, right? The particular data that you need is not always going to be the same thing, but for our purposes here, that's the data we need. Okay. So in the primes data source, as usual, I'm going to make a constructor. And so this is going to be public primes data source. Not going to take any arguments to the constructor. And I just need to initialize those values to what I want them to be when the application starts. So current is 0, max is, say, maybe 100,000. And the primes list is going to start as empty. Right? So that's our initial state. That's where the application will start out. Now, the other thing I'm going to need here is the way to communicate that live data objects. So those live data objects, basically it provides a way to communicate a value between different things that might want to observe that state. So basically it's a wrapper. Live data, you can make it as a wrapper around any primitive type, any list, or anything I believe that is, basically any type you want it to be, with the exception of things like contexts and views and such, but any sort of model bit that you want. So in here, I'm going to add some additional variables, some additional fields, and these are all going to be of the type mutable live data. So here I'm going to put mutable live data, Now, it's a generic thing, so I do have to specify what kind of data it's going to hold. So in here I would say long, and here I would say current live data, right? So this is basically a representation, you know, a wrapper around current, and I need another one which is going to be a wrapper around the max and we're going to have another one here, mutable live data, and this is going to be list long, and so this is the primes live data. So I basically have a mutable live data that's wrapped around each of those. And the reason I'm using mutable live data here is because it allows me to actually, what do we call, mutate the data. It allows me to change the data that's inside of that object. So as you're building up the data source needs to have those typically as mutable live data, whereas the rest of the application will just see it as live data. So the only class that really has access to change that data is basically the data source. Everybody with me there?
Yeah.
So
Yep.
the way that I construct those now, here I'm going to say current live data is equal to new mutable live data, and I'm going to pass in current to initialize that. Similarly for the max, I'm going to say max live data is equal to new mutable live data max. And then finally we've got the primes live data is equal to new mutable live data, pass in the primes. So now I've got a wrapper around each of those three. Now, it's worth noting that these effectively are duplicate copies of the data because it's also storing a copy inside of those mutable live data. So in reality, I don't technically need these three variables anymore. I can actually eliminate them. They aren't really needed anymore. I could just have these three and that would work. But for kind of keeping this example, trying to keep this example simpler in explaining some of the things that may go on, I'm going to leave both of those things here for now. But in reality, it's worth noting that you really just need these three. You don't actually need these other ones here. Those are simply copies. Okay, so let's think about what we want to add in. Now, normally I would add getters for these three objects, but as I noted, you know, these are copies. So because of that, I'm not actually going to provide getters for those three. I could, but I'm not going to. So I'm going to force any read to this data to go through the live data objects, right? So they can't read these fields directly. So the getters I'm going to add one for get current live data, get max live data, and get primes. Oh, nope. Get primes live data. There. Now, by default, you'll notice that it automatically put those in as returning mutable live data because it just auto-generates it with the same data type. But it is really important that as you're building this up, you need to return a live data, not a mutable live data. That's really important. If you return the mutable live data, then you're breaking your encapsulation. Because the whole idea of the data source is it needs to encapsulate and control the changes that can happen to the data. So if you expose the mutable live data, you break your encapsulation. Okay, so it's really important to make sure that your getters just return the live data, not the mutable live data. this works implicitly just by changing the data type because mutable live data is a subclass of live data. Any questions so far?
No.
So we haven't really seen how this live data is going to be used yet. But basically the way that this works is that you can set up what we call observers to watch for changes to that data. So I can set up my UI to say, let's observe the live data, and anytime there's a change to that data, here run this code. So that's what we're going to be doing, is we're going to say, when this data changes, go update the UI. Now, I do need to add some setters in here because my background or my worker thread is going to need to change some of this data. So if I think about, the operations that my background thread needs to do, one of those operations that it needs to be able to do is set the current, right? We need to be able to set their progress so far. So in here, I'm going to add a method called setCurrent, which is going to take the current. I'm going to go ahead and set that local variable, but I also need to update the live data to tell it that there's been a change. So in here, I'm going to say this dot current live data, and what I need to call is the method post. There's two methods here on the live data, specifically mutable live data. This is not available on live data, just mutable live data. There's a post value and there's a set value. So a set value just directly sets the value and basically triggers the events on the same thread where you call set value. Whereas post value triggers the events on the UI thread. So post value is the one you want to use when you're communicating from, like, this is called from a worker thread to a UI thread. So basically anytime, pretty much you're going to use post value over set value to make sure that, the events get fired on the right thread. So post value we call on the background thread, and then we observe the value, and that's going to be called on the foreground thread. So in here I'm going to say post value current. Okay, and so that's going to send out and tell our observers there's a new value, and here it is. Now, one of the things I may want to do in terms of annotations, there's some newer annotations that have been added to Android. One of them is main thread and one of them is worker thread. If I add main thread, I'm saying that this function should only be called from the main or UI thread, versus worker thread says that this can only be called from a worker thread. So it will give me a warning, potentially saying, hey, you're doing something you shouldn't be doing because this should not be done on the main thread if I accidentally try to call this method on the main thread. I don't need to mark any of these with either of those annotations, main thread or worker thread, because they're actually going to be called from both threads. Okay. But this one,
but line 41, so it won't break if you don't put that. You're just limiting where it can be used.
Right. It won't break without that. It will work without that. But that's giving me some additional documentation of how this is meant to be used, and it'll give me some warnings if I misuse it.
Okay, I get it. With any of these annotations, is that case in any of them, is that they have the potential to be used in the wrong context, but they won't ever break it? Is that true across the board?
Typically speaking, yes. Typically speaking, the annotations you add or leave out are not going to cause your program to crash. Large in part, the annotations are mostly used at compile time just to give you better hints in your IDE. Very rarely are these used at runtime. Sometimes they are. There are some annotations that are used at runtime to change the behavior of your program, but for the most part, these are a way to let Android Studio give you better hints about how to write your code. and to warn you about potential pitfalls. So that's what we're doing here, is we're warning the user about, hey, you're calling this on the main thread, you really shouldn't do that. Cool?
Okay, thank you.
So I need one to set the current. I also need another one to add a prime. So I'm going to go in here, I'm going to say public void add prime. And so that's going to take a prime. And so I'm going to say this dot primes. We're going to add the new prime. And then I also need to let the primes live data know that there's new data. So we're also going to post it here. So I'm also going to call post value there. And just like the previous one, this is changing the data. This is stuff I only want to do from the background thread. Background thread is going to be doing all the work, so it's going to be the only one changing the data.
So post value knows how to add a value to a list?
It doesn't. So what I'm telling it is that there's been a change to the list that's there.
Oh, I see.
It just says that there is some change to that list. It doesn't tell it, like the observer will not know what the change was. It just knows that something changed.
Mr. Smith, my prime is showing up in red on, technically that would be your line 49, mine too. My prime is showing up in red. I don't know if I missed. Oh, never mind. I know what I missed.
Okay. Yeah, I've got one called prime and another called primes. So watch your S's, watch your plurals and your singulars. Another thing I know here is that as I'm going through and adding primes, that's also should update the progress. So one thing I could do this is, anytime I need to add a prime, I could call both set current and add prime. But I'm going to make this easier in terms of implementing the worker and go ahead and just do both of those things. So when we find a prime, I'm also going to set the current to the prime we found, because I know, okay, so we checked that number, we're at least that far. So I can update that as well, and then say this dot current live data dot post value the prime.
So where do we add the actual value? That just notifies there's a change. We're doing that next?
Yeah. So these two methods are going to be called from, as you see, the worker thread. So the worker is going to call both of those two things. And then the activity, the front end, is going to observe for those changes, right? So the worker is going to post new data, and the activity is watching for that new data. Does that make sense?
Right. So will there be a noticeable lag in the program because it's got this extra work to do?
No, actually, this will be quicker than the previous version.
How's that? Because the way I understand it is we got this pseudo database that's keeping track of everything, so that when we switch activities, we go to another app and then come back and keep running, and nothing's having to start over.
The difference is there's a lot of overhead in sending broadcasts, and so live data actually has less overhead than a broadcast.
Wow. All right. That's a surprise, but
yeah,
I accept it.
Yeah. So this one will actually be faster than the other one. Okay. So let's go to one of the things I need to do. I've got this data source. In order for it to be used on both sides, right, I need to have that in a centralized place, right? And so one of the things I've already shown you is that usually when I create these data sources, right, usually I'm going to have them owned by the application object. And so that's what I need to do so that both the worker and the activity can have the same view of the data source. Because if I just construct a new data source on both sides, they will not be looking at the same live data object. Does that make sense? So in here, in the primes app class, I'm going to add a new field, private primes data source, And so in here, we're going to construct it. And so primes data source is equal to a new primes data source. And then I just need a getter for that here. So get primes data source, and that way with the getter and that field in place, now both sides of the application, both the worker and the activity, can have that same view of the data. They can both get the data source through the application. So everybody got that, the changes that were made to the application?
Yeah, I do on my end.
Yep.
So let's go
Yeah.
back. Huh?
I got one question. So
Yes.
this is, we're going to use this here, this Primes app that owns the application, right? That is the means to pass the data from the back to the front.
That's one part of it. Yeah, that's one picture.
Yeah, right. I mean,
So-
that's what you're going to call that on your main activity
Right.
to get it, right? Get Prime's data source.
Yeah.
And
So-
okay.
One of the things you'll hear sometimes in the software programming world is you'll hear of what we call a singleton, or a singleton design pattern, which honestly is not a great design pattern, and I would really call it an anti pattern in a lot of ways. But the point of a singleton is to have just one instance of an object. And so in this case, what we want is we only want one primes data source to exist. And so we could do that using, there's a bunch of different patterns. I've seen at least 5 to 10 different variations of singleton that people have written in Java. In reality, most of them don't work. Most of them have issues. But the point is, there's actually no good way to write a singleton in Android. There is no way to actually implement a singleton in Android that works and doesn't have bugs. So you don't want to implement a singleton in Android, despite what some of their guides might tell you, because they basically don't work. So what you do instead is we take advantage of the fact that the application only gets created once and exists for the life of the application. So effectively, the application is a singleton. There only exists one copy of the application. So anything that we hook up to the application and is owned by the application, so this primes data source, now I know there's only one copy of it. Does that make sense? There's one shared copy because the application owns it. So if you ever see anything online that's, whether you're looking at a tutorial for Java or you're looking at a tutorial for Android in general, and they say use a singleton to do this, what you really should do is put it in the application instead of creating a singleton. So going to our worker now, and so our worker needs to get that data source. Right now we've got this hard-coded here, right? We've got a hard-coded number 2 and a hard-coded max, but I'd like to pull those from the data source, and I'd like to also then, if I pull it from the data source, it actually also enables me to resume from wherever we left off. Rather than restarting every time, we can actually resume from wherever we were. So we won't need the local broadcast manager anymore, so I'm going to ditch that here. But we do need a reference to both the application and the data source. So private primes app, this is going to be our app, and private primes data source. So I'm going to add those two fields in replacement for what we had. And then the app, I'm going to use a little trick. I know that the application is a context, and as it turns out, this context that we're passing here is actually the application. So if I want to get the application here in the worker, I actually just, all you've got to do is downcast the context as the application. There's actually no way in this side to call get application, but that's how you get the application, is it's actually this context that we're being passed. So we just need to cast it. And then from there, we can get the data source just by calling app.getPrimes data source. Cool. So we have both of those values.
Would you be able to do that if you didn't cast it? I guess not, huh?
No,
if you didn't, if app equals context and then app, it wouldn't work.
Because it's like the primes app is a subclass of context. Because it's a more specific version of a context. So that's where I have to tell it that I want to do an explicit downcast. If I were to leave this off, it's going to just tell you that, hey, these data types on the left and right, a context is not a primes app.
Is there a way to tell by, say, like that context? Okay, I know now that the app is is downcastable. You can downcast the context into the app, but how would you know that without digging a deep dive into the docs? I mean, is there do you right click, or is there something that shows what you can do, or?
There's not.
Maybe, okay.
There's not. That's something that you just have to remember that you can do.
Yeah, if you tried to downcast something and it wasn't appropriate, like let's say you try to downcast that into an integer, it'll throw an error, yeah?
Yeah, then it won't work. And it actually wouldn't. It would, if I tried to downcast this to integer, it's going to not even compile because there's no relationship between the class's integer and the class context, right? So in here it's just going to tell me, hey, these are not convertible. Like there's no relationship between those two. But if I were to say, let's cast it to main activity, well, main activity as a context, it might give you a different error. But anyway, no, there's not a good way to know that that is the application, but you just kind of know that, hey, what it's passing me is a context. A context can be, like the subclass of context, there's a few different ones. Activities are contexts, services are contexts, as well as applications are contexts. And so I know it's one of those, but in order for a worker to work, especially because a worker doesn't work, like it can do work even when your application's not up, it basically by definition has to be an application context because of that requirement that it can be working when your application's not running. Does that make sense?
Okay, yeah.
So that's yeah. All right. So we've got those values, and now I need to figure out what the current and the max are. Well, I can get those from my data source. So current is now data source dot get, And you can see I can get current live data. Now I have a little bit of a problem here because I need a long, but I actually have a mutable live data. So sometimes you need to just inspect and get the current value. You can call anytime on a live data, you can just call get value. That will give you whatever the current value of that object is. So that's all I need to do, is get the current live data and then call get value on it. Same way with the max, I'm going to say get max live data dot get value. So that will give me whatever the current value in there is. Okay. Any questions so far on the constructor, or how we're getting that data initially? Okay, so walking through the do work method now. Remember previously we've been sending a broadcast here when the application starts. Here we don't necessarily need to do that, except that I think I'm missing one thing. I was using that start and end to do to notify the front end of one thing. I was using that to notify it when the worker starts and the worker stops, right? So at least as it stands currently, I don't think I have a way to know whether or not the worker's running. Does that follow?
Yeah.
Like I could ask, and technically I could ask the work manager and go get the worker object. But I think, thinking back, I think I probably need to go ahead and go into the primes data source and just add another field to know whether or not it's running. So I'm just going to add a Boolean in here for running, add a live data to it. So that way we have a way to say, hey, is it running or not? So mutable live data, this is a Boolean running live data. And so initially running will be false, it won't be running. And my running live data equals new mutable live data running, and I need a getter for that as well. So get running live data, and I need a setter as well. So public void set running Boolean running. So this dot running is equal to running, and this dot running live data. So very similar to how we've set up the other things, so just adding another Boolean in there called running. I do want to mark that one as working thread as well. So that way when we start running, we just need to set that to true, and we can show or hide the circle based on that. Okay. So
don't forget to change the mutable live data to live data.
Correct.
For line 33.
Yes. Yeah, I forgot to do that. I do need to change that to live data. So back here, basically what I want to do is when we start, I'm going to say data source dot set running. We're going to set it to true. There we go. So that's enough to tell it that we've started. Let's just say set running is true.
Is there any chance you can go back to your code real quick on a prime data source?
Yes. Got it?
Yes, thank you.
So we're going to set running initially as true. In terms of what we need to then broadcast here, so basically every time we find a prime, we're going to call data source dot add prime, which we set up a minute ago. So I'm going to add the current value at that point. Okay, that's all I need to do to notify the front end. And then when we get done, I need to switch a few things. So in here, I'm going to say data source dot set running. We're going to set the running to false, and data source dot set current, and I might set that to max, or I guess current. And similarly, if we get done here, regardless of whether we finish successfully or we finish unsuccessfully, we really need to set both of those things. In fact, I can probably just move that outside of the if statements because we're going to be doing the same thing in both cases. And so doing this is also going to make sure that we can pick up where we left off the next time the task picks up and starts running. Questions?
Yeah, I'm a little lost trying to figure out the code here real quick, but I think it's just I'm trying to read yours and compare it to mine.
Yeah. Well, you'll notice I removed a lot of things. So anything that had to do with broadcasts is now gone. So instead of sending a broadcast, I'm just calling methods on the data source. So set running, add prime, set running, set current. Any questions?
Yeah, can you go back to prime data source? I think there's one thing I'm missing there.
Which part?
Set running?
Set
Yeah,
running?
okay, there we go. Yeah, okay. Dot post back.
If you compare set
Okay.
running to set current, they're almost the same thing. It's just a boolean instead of a long.
Okay, and then inside back on the other file, we just put it under do work, right? We didn't change anything on if the only thing we have in current greater than max is the log and then return.
Correct. Yeah.
And then the log and return under else. Yeah, okay.
Yep. Because at that point, I just need to set those two things regardless of which route it's going.
Okay, that's it. We're done then.
That's it. So we've refactored the worker to use the live data stuff instead. And you'll notice it actually, like the worker really doesn't know a lot about live data. It just knows, hey, I'm calling methods, I'm doing stuff on this data source. From there on, that data gets propagated to the UI and is kind of invisible to it. What were you wanting to look at, Jonathan? if we run the application as is, we won't actually see anything happening anymore because the main activity is still expecting those broadcasts to come through, which they're not coming through again anymore. So we're not actually going to be seeing it do anything yet. So we need to change the front end to listen for and watch those live data objects now as a way of updating the UI. So going over to main activity, you remember that I had to actually add a decent amount of code to support these broadcasts. So things I had to do, for instance, I did have to add in the local broadcast manager, the broadcast receiver, as well as the intent filter. If I'm using the live data here, I actually don't need any of those three things. So I'm going to cut that out. And in fact, contrary to what you might think, I'm even going to cut out the list because I don't actually need any of those things anymore. Because I'm going to be pulling the list from the live data. So what I do need in here is a reference to the live data objects. So live data, this would be the current, so it's going to be a log. So this would be current live data. I need the max live data.
Did you delete the list of primes?
Yes, I did, because I don't need it anymore. I still need the adapter, but I do not need the list. So instead, I'm going to just have a reference to the live data, which has the list. And this is basically the same three things that we see in the data source, is the current, the max, and the primes. Oh, I also need a reference to the running data as well. Live data, Boolean, running, live data. So again, because there's no broadcast coming through, that's why I don't need all of those other things that were there. Okay, so in terms of filling this out, I'm going to actually, this code here, I'm going to just comment all of that section here out. So everything that we're doing with the broadcast manager, the receiver, the intent filter, I'm commenting all those lines out for the moment. We can eventually just delete them, but I want to have them for reference at least for now. Also remember I removed the primes list, so rather than constructing that here, I'm just going to pass null when I build out the recycler view. So that's one of the reasons when I implemented getItemCount, I wanted to make sure that I check for null, because initially I do want to put null in there. I did forget one thing. I do need to have a reference to both the application and the data source. So I need to go back and add that in here. So private primes app, and private primes data source. So a reference to those two things. So that's kind of the setup there. In terms of now connecting up and working with that data, we now need to actually bring the data out of the data source and get the UI in sync. So I'm going to say let's initialize the activity, and so I need to get the application. So app is equal to primes app get application, and the data source is app dot get primes data source, and now I can get the live data objects that I need. So like running live data is equal to data source dot get running live data. The current live data is data source dot get current live data. The max get max live data, and the primes is equal to data source dot get primes live data. So I'm pulling out all of those live data objects that I'm interested in. Maybe I'll call this get live data. Okay, so I pulled those down, and I need to actually update the UI now with the data that's there. So if we think about some of the things that we were doing, so for instance, if it's running, we were setting the circle progress bar to be there or not, to be visible or gone. So I want to say if it's running, so maybe boolean, or no, I'll just do it the other way. So if I say here my circle progress bar, circle progress dot set visibility, and so I want to do running live data dot get value. So we're going to grab the current value. If it is running, then we want to set it to visible. Otherwise, we want to set it to gone. So it's either going to be visible or gone based on whether or not it's running. Other things I want to do, I want to go ahead and set the progress as well. Now I think I may want to do that. I may want to actually track the current and the max in a local variable. I think did I end up doing that with my example? Yes, I did. So I did find it easier to go ahead and track those rather than getting them every time. So current, private, long, max. And maybe, yeah, no, I'll just have current max. Because the problem is I need both of those to calculate where the progress bar should be. So current is equal to the current live data dot get value. The max is equal to the max live data get value. And then we can update our progress bar based on those things. So the horizontal progress, set progress, and so you remember that was 100, take 100 times the current divided by the max. I do need the longs there. All of that gives me a long, which needs to be downcasted as an integer. So we'll do that here. cast that from a long to an integer, so we can update the progress there. And if I'm thinking about, well, I don't think I need to do anything with the text there. Oh, but I do need to set the recycler view up. So the adapter, I'm going to say adapter.setItems, and that is going to be primes live data get value. So the adapter is pretty simple. I'm just saying take that data, throw it in. So that's just me going through and initializing the different controls that are on screen with what the current data is. I haven't set the text view there, which I'll come back to that one. But if I run this here, one of the things we'll see is stuff still doesn't happen because I'm only actually doing this once, right? So you do have to do an initial setup there to have it have the initial values. If I turn the screen sideways, that actually, you remember that configuration change triggers the activity to be destroyed and recreated, and you will see that there's some updates in terms of things do move because am I turning it the wrong way? There. Things do update because it's still running in the background, and so if I take a new snapshot anytime it's created, I'm just getting a single snapshot which is reflecting where it is currently. But I'm not getting that behavior that we want, which is where I'm watching for changes. So in addition to all that, I do need to observe the live data, and that's where we tell it to watch for changes to live data and update the screen based on what's occurring. So in here I would say, for instance, for the running live data, I'm going to say .observe, say this because first thing it needs is a lifecycle owner. Main activity, long story short, is a lifecycle owner. And I need new observer. So we're going to create a new observer for that Boolean. And basically anytime that changes, I'm going to use the value that we get out of here. I'm going to change that to value. So if the value changes, I can automatically set that the way we want to set it. So if it's true, then we're going to make it visible. Otherwise, it's gone. So you observe and get an event basically any time that there's a change to that data. So that observation is what's going to cause us to actually have and see differences. So if I also add in here, maybe just jump to the primes live data and say observe that, I'm going to say this new observer. And so when we get that, then I'm going to say adapter dot set items, and we'll take the value. So we should see if I start putting those in, we'll see the progress, the circle progress bar show up. We'll see values. I haven't put in the we're not observing the current live data, so this progress bar is not updating yet. We can do that here in a minute. Other thing I want to do, I want to make sure that this scrolls up. So just like we had done previously, I need to do recycler view dot scroll to position, and this would be value dot size -1. So with that in place, we should actually see some stuff happening. There we go.
I got a question. Is it done by design where when we auto implement these properties, say when you start typing new observer the first time, on purpose, it seems that on line 131, what would be 131 when you enter that, there is no semicolon. Why is it like that? Is there a reason?
No semicolon which line?
Well, you have it now, but I think you had to type that, right?
Yeah, I did.
The other stuff was auto-driven. Why does it do that?
Well, because it doesn't know that I'm at the end of the line yet, right? So the part that it auto-generated was from here to that curly brace, right? Because that represents that object or that class, that anonymous class. This closing parenthesis, right, that's the end of the observe function, right? And the Android Studio doesn't know that that's necessarily the end of the line, because it could be that I called that and then chain another method to it potentially, right?
Okay.
I think observe is a void return type, so yeah, it doesn't return anything, so I'm not going to chain anything to it. But if it weren't, then I could potentially call more things that wouldn't necessarily be the end of the line. So
I think we've earned a break.
Yes. Yeah. Let's take a break. Let's take a break. Let's take a, what do we want to call it?
Just went to 20 since we're already almost like halfway through the class.
I was gonna say let's do a 30-minute break today.
Woo wee! All right.
Good.
So
2:42.
Yeah, 2:42.
All right, awesome.
Okay, welcome back. So we're actually almost done with this example. We hooked up, as far as the worker, all of that's done. The data source is done. The last two bits that we haven't done here is to just update the progress bar and the text here as we get new data. So in terms of updating the progress bar, the main thing that we're watching for is when the current number changes. So I'm going to go current live data dot observe. This is the lifecycle owner. New observer. Change this from a long to just value. And so when we get that, we know that the current has changed. So I'm going to say current is equal to value. And then I can just update the progress bar to the new calculation, which we had here. If I copy it correctly. So, it should be 100 times the current divided by max. Cool. And so we have a progress bar running. In terms of getting the text to show up here, remember we were just setting that to the highest number that we've seen so far. So that would be the event, the thing that changes that we would need to listen to is for when the list of primes changes. So in here we just need to say, well, if that changes, then I want to go grab the last one in the list. Now, just to be safe, I want to make sure I check that the list isn't empty. So I want to check that the value is not null and the value dot size is greater than 0. So if there is a list and that list is at least has at least one thing in it, then we can show that thing. So in here I would say the highest text, set text, and that would be to whatever the last thing in the list is, which would be value dot get. So I'm going to get the last one, and this would be value dot size minus 1. And then finally call toString on that. So get the last element in the list and turn that to a string, and otherwise we're just going to set the text to null, which really just sets it to empty string. So as simple as that, we've got those pieces working, and if we turn it sideways, all of that's great. All of that stuff is still preserved because it's being stored in that data source, so we don't really have to worry about restoring the data, at least in this case, because everything's there. There's nothing that's really local to and is only stored in the activity. I could also, in there, while it's running, I could go to the battery, shut it off, and we can see as soon as I pull it back up, it's going to pick up right where we left off. Because remember, when we start that worker, the first thing we do in the constructor is we pick up from wherever the current was previously. So any second now, it's kind of variable as how long it takes to resume. You can see it immediately. You can see it there picking back up. So honestly, I'd say that using live data, at least for this program, is a lot less code than doing broadcasts. Sometimes it's the other way around. Sometimes a broadcast is a lot less code than the live data. It really depends on what you're doing. Questions?
Well, if I speak for the whole class, I mean, at least for me, I'm blown away. It's a lot of code, a lot of stuff going on, and well, if we got this as a guide, I suppose we'll be all right. What would be what's our lab for this one?
Yeah, so that's a good question. There's a lot of stuff going on here. You're right. How this fits into here, we're at the moment we're just talking about how to pass data back and forth, right? And so, in this example, I'm just generating, a list of primes, and so that's a relatively simplified example in some ways, because really what we're going to use this for is for doing all sorts of network operations. So, for instance, if I want to say get the latest news stories from NPR, there's actually a lot of commonality between this and that, in the sense that you'd have your worker thread go get the stories, you put that into live data, and then you just kind of watch the live data in your activity to populate that recycler view. So, I mean, this has a lot in common, and what I'm kind of trying to build you up towards is using this for network operations. Does that make sense? So, like we talked about how to do, with 7.2 earlier this week, we talked about how to pull things from the internet. Well, that would then be your code, the code that you're doing network work, that's now going to be in do work. So that's kind of where we're heading. I've been trying to think about, what's a good lab as a stepping stone, and the problem is there's just a lot of steps and pieces going on here that I'm like, okay, well, what do we do? What do we do as a lab? So, one of the things that I would say, I think maybe what I would say is what makes sense for the lab is maybe to continue with what you started with 7.2, right? Remember, you found, I asked you to find a REST API that you could connect to and pull data down. Basically, what I would say is take that work now and move it from a async task to a worker, is basically what I'm thinking.